America's Declaration of Energy Independence. And we're going to try to show you why we call it America's Declaration of Energy Independence as we go here today. My name is Dennis Lee, and I'm the Director of Research for Better World Technology. Better World Technology doesn't sell anything at all to the general public, so you can relax. United Community Services of America is a national distribution network. We build technologies for them. They have a national network of dealers all across America, and the primary purpose of this show initially was, it's become different because God has different ideas than we do, but initially our thought was that we were going across America showing our technologies and showing any new advancements that we had to the dealer network. And then of course if you're here and you're not a UCSA dealer, it's because you were invited by one. And if you read an ad or something, then once again you were invited by a dealer to be here. So we're doing the show for the dealers and for their invitees. We also, the show has taken on kind of a life of its own. This is about the 12th show that we've done across America. We're going to 34 cities, and we're doing the same show in 34 cities. Actually, it's not the same show because it keeps changing all the time on us. And so we get new technologies and we add new technologies and drop things that weren't as interesting. So actually, if you come to another show a little bit further down the road, it'll be a little bit different show than the one you see now. So, but the main theme that has been continuing is that we're ending the last show in Philadelphia. Now, Philadelphia is the place where the Declaration of Independence was signed. And isn't that funny? We call this America's Declaration of Energy Independence. And so we just went and rented a bigger hall in Philadelphia for a bigger group of people. And anybody that sees this show that wants to come to Philadelphia, you're invited by us to do that. By all means, please do. We're going to sign a Declaration of Energy Independence in Philadelphia. And actually, we're going to begin at that point in time re-evolutionizing the United States of America and possibly the whole world into whole new energy technologies. So, but I'm here to tell you now, and all I can do is tell you, and then we're going to try to show you some of it, but I'm here to tell you now that the technology exists right now to completely eliminate all forms of pollution worldwide. If you are putting up with any form of pollution at all in the world today, there's no good reason why you are. Any form of pollution. If you're taking gasoline right now and putting it in a car, there is no good reason why you're doing that. If you're taking any kind of fuel for a jet or a train or a plane or any type of mechanical device, if you're using fuel that pollutes the air, there just is no good reason why you're doing that. None. Also, if your electric company is using radioactive isotopes to make your electricity and subjecting us all to major risks, there is no good reason why they're doing that. If they're using coal and they're producing acid rain that's destroying our environment, there's no good reason why they're doing it. There is no good reason. So we're going to show you that there's no good reason. Now there's a reason why they're doing it, but it isn't a good reason. Yeah, I guess for them it's a good reason. It's called greed. And it's kind of like everybody's stuck in yesterday's technologies because they're all invested in them and they're trying to just milk as much money out of them as they can before we move on with life. But see, we feel like it's time to move on. So as you're going to see here today, we're going to show you some alternatives. And we call our technology the alternative. And so we're going to demonstrate some things for you up here that's hardware. We'll actually run them for you and demonstrate them. Other things it was impractical to get. We couldn't get them here, and so instead we'll show them on the television screen. So you'll see some things on the television screen, and then some things you'll see up here on stage, and then other things we'll just illustrate for you on the big screen with slides. And so we'll try to at least give you a glimpse or an idea of why we say there's no good reason why anybody is doing anything to pollute our planet right now. Go ahead, Tommy, with the first slide there. Now, Better World Technology, and by the way, we have no enemies. Better World Technology has opposition. We have people who think differently than we think. We don't think that makes them our enemy, it makes them our opposition. We're not called Bitter World Technology, we're called Better World Technology, and we're here to make a better world. Better World Technology advanced some technical theories that were reviewed by the Science Committee of the International Inventors Hall of Fame this year. And I'm proud to announce to you that we were all inducted, the entire group, our whole research team were inducted into the International Hall of Fame this year. So we got the award for the Advanced Technical Theory Award. So it already has been, to a large extent, it's had pretty strong impact on the environment in which we live. But we're not, what's the phrase, you ain't seen nothing yet. We haven't even got started yet, okay? It isn't going to be theory, now we're going to get into the actual practice. So this is a prelude to that. Now the first technology that I'm going to show you, some of these technologies will be easy to understand, some of these technologies will be more difficult. And so the ones that are more difficult, we'll spend a little bit more time on. The ones that are easy, we'll just show you a slide. And the first slide that I'm going to show you is a slide of a technology that we developed out of need. Now, you know who the mother of invention is. Necessity is the mother of invention. And this invention came from necessity. Now, I don't know if there are any cat lovers in this crowd at all. Are any cat lovers here? Got any cat lovers? Now, I own a cat, and believe it or not, I'm still a cat lover. So I'll still confess I'm a cat lover. And my little critter, I wanted to take my cat to the veterinarian one day. And in order to take a cat to the veterinarian, it's best that they want to go. But when they don't want to go, that's when you discover what these things are all about. Claws. They got claws, and believe me, they know how to use them. Now, it's impractical to demonstrate this next technology for you, so I'll show you a slide of it. But when I show you this slide, I want you to just look at this slide of this invention and just use your imagination and see if this will work, okay? So I'm going to show you the slide, let you use your imagination. I want to see how creative you guys are, and see if this technology will work. Now, I'm not going to show you a demonstration because it's impractical, but I think you can figure it out just from the slide itself. Go ahead, Tom, let's get the slide up here. You guys tell me now. Will that technology work there? The cat carrier. Sells for $3.99 and just a fit-in cat. There's that little critter right there. Now, I'm told that this will also work on oil company executives and electric company executives and pesky politicians. I'm told to work on them as well. So this is the first technology, and as you can see, you can figure it out. I didn't even have to demonstrate it for you. Next slide, Tommy. Now, the first real slide of the show here is supposed to be a cartoon. But there's one problem with this cartoon here. And the problem with this cartoon is it isn't funny. Now, cartoons are supposed to be funny, but this one isn't funny at all. Over here, we've got some people. They got a little squad here, and a whole army of people back behind them. This is obviously the guy in charge. And he's over here, and these guys are trying to talk him into looking at this invention over here. And we got an inventor. He's got a beard. I don't know why, but he's over here trying to show these guys a machine gun. Well, this guy's so busy with the battle that he's got over here, he can't take time to see somebody with a machine gun. So he says, no, I can't be bothered seeing some crazy inventor. We've got a battle to fight. Now, you can probably see right away what's wrong with that picture there, right? However, this pretty much sums up the attitude of the Department of Energy in the United States of America, pretty much sums up the attitude of the government of the United States of America. These people are so busy trying to go out and solve the energy problems that they don't have time to talk to anybody with any kind of solution for the energy problem. Now, every technology that you see today, all of these technologies have been totally, absolutely, and completely ignored by the Department of Energy of the United States of America. Well, they haven't really been ignored. They've been seen, but then after they've been seen, then they've been ignored. And so we have had meetings with people, and there have been documentations, and there have been documents in their files about these things, but then for some reason they just close the file and that's the end of it. So I thought I'd just let you know about that. Now, that's the reaction of the Department of Energy, but you see, we're not doing this for the Department of Energy, so we proceed. Next slide, Tommy. Now, I developed the world's most efficient heating system. I've already done that. And all the way across the United States of America and throughout the world, I developed the most efficient heating system in the world. This heating system is also the most efficient heat pump in the world. It is also the most efficient solar system in the world, solar energy system. By the way, God invented the solar system. I didn't do that. Okay, but the solar heating unit, I did do that. Now, my solar system would be like, see these panels out here? They look kind of like solar panels. Well, this solar unit right out here is so efficient that it can suck solar energy out of a snow blizzard in the middle of the night. Is that the best solar unit that's made? So in the middle of the night, thank you. Oh, hold on, because we can't do that. Otherwise, it'll take us another hour to get through the show here today, because we're going to show you really good stuff. Now, so this one can suck solar energy out of the snowstorm in the middle of the night. That's how good it is. Now, how many people here know that actually solar energy is pretty much most of the energy that there is? If you burn gasoline, that's stored solar energy. And by the way, in the middle of the night, the energy that's in the air, that's solar energy too, because the sun heated everything up during the day, and at night, everything's giving their heat back up. That's solar energy. So even when the sun isn't there, you can still take solar energy out of it if you use a refrigeration process. Now, this solar system is exactly that. It's a refrigeration process. I'll tell you, I'm going to have that completely torn down before I get done here. But nobody, see, this all looked really pretty when we started. No problem. Now, this right here is my collector. This is a solar collector. You see a piece of metal? It's just a piece of metal. And it has two sides, and it has little veins in it. You see the little veins in there? So the little veins run through the middle of this, and so what I'm doing is I'm just taking a fluid and running it through those little veins in that plate of metal. I'm going to pass this around to the room, and everybody in the room can have a chance to grab hold of that. That's a small piece of that panel right there. That's an 8-foot long, 3-foot wide collector. That's an evaporator panel. Now there are two of them, one in the front, one in the back, and we're going to be demonstrating this for you in a few minutes. What we're going to be doing is we're going to be taking the solar energy, or the heat energy, I should say, out of this room, and then we're going to be making hot water from the energy we take out of this room. Now the way we take the heat energy out of the sun in the middle of the night in a snow blizzard is, we take something and put it through that panel, and we're going to capitalize on the second law of thermodynamics. The second law of thermodynamics, very quickly summed up, says, hot goes to cold. It's just that simple. You guys are halfway to an engineering degree now, and you didn't even know it. Hot goes to cold. And so if I take and I put something outside, and it's the coldest thing outside, and hot goes to cold, won't everything outside give all of its heat to it? Hot goes to cold. So by merely creating the coldest thing outside, taking refrigerant, running it through that panel, everything that touches that panel that's warmer than the boiling point of the refrigerant I put in it will put heat into it. And the boiling point, the point at which it becomes a gas, for the stuff I put in there, is 40 degrees below zero. Now, if it boils at 40 below zero, what is there outside that will touch that panel that is not warmer than 40 degrees below zero, day or night? Snow, wind, rain, sun, sleet, doesn't matter. So see, any time, 24 hours a day or night, I can take energy right out of the air, because it's always warmer than 40 below. Now, wouldn't that be sort of like a perpetual energy source? If it happens 24 hours a day, 365 days a year, then wouldn't that be perpetual? It happens all the time. And so, at least for whatever environment 40 below is okay, that would be perpetual energy source. Now, there's no such thing as perpetual energy, but I'm just showing you a perpetual energy source. Okay? Now, anyway, you know I'm setting it up already. All right, now, so anyway, I can then take the energy out of the sun, wind, rain, snow, sleet, and hail. Next slide, Tommy. Now, what happens is I take this refrigerant, and that's the refrigerant right there. Now, the refrigerant that I use is natural organic refrigerants. You're sitting there saying, well, wait, refrigerant, is that Freon? Because Freon destroys the ozone, right? No. And we don't want to use it. We got an informed audience. Well, the scientists say Freon destroys the ozone. Okay. And then according to the scientists anyway, Freon destroys the ozone. And then you get up there and that'd be a bad thing to use in there. But you see, we don't use Freon. We use natural organic refrigerants, an HC12A and HC22A, replacements for 12 and 22 for what we used to call Freon. And by the way, if you thought that it doesn't destroy ozone, I agree with you 100%, because how does something heavier than air get to the ozone layer, number one? But number two, it's supposedly leaking out of all the refrigerants and it's causing a hole in the North Pole and the South Pole. And you just sort of have to ask yourself this question. I wonder how many refrigerators there are in the North and the South Pole. And what do they use them for? Anyway, I'm not going to get into all of that stuff, but we're not going to hurt the ozone in any way because we have a natural organic refrigerant. Now what's going on right now is people are saying that you got to change all of the refrigerant that you got in your car, your air conditioning unit, and it's going to cost you a fortune, and then they got to suck all the old stuff out of there and stuff. Well, guess what? If you buy all of that, or if anybody ever tries to sell you all of that, what you should do is pick up a phone and call our company. And the reason why is because these refrigerants right here, you can leak out to the environment, you can do anything with them, they're not even controlled by the EPA. There's absolutely no control over these refrigerants whatsoever, and they're very cheap, very economical, and so you can either replace it with these things or you can replace it with all that other intrigue that everybody has got the American people into. Anyway, you should call us if somebody wants to charge you a fortune to change out your air conditioner. Now, the unit over here with that refrigerant in it, the refrigerant's going to the panel, and if it boils at 40 below, that means it's turning into a gas. And so it's going from a liquid into a gas. When it's a gas, it's going to hit a compressor. The compressor is going to take this much gas and shove it into the small space. When you compress gas, take this much gas and throw it into a small space, what do you do to the heat of the gas? You elevate the temperature, you also elevate the pressure. So we have a low pressure, low temperature gas going into the compressor. Compressor hits it, now we got a high temperature, high pressure gas. Now the temperature of that gas can be 250 degrees Fahrenheit. Is that pretty hot? So I can get a hot gas coming out of that compressor in the middle of the night in a snow blizzard that's 200 to 250 degrees hot. Now with that hot gas, if I run that hot gas into a line, and I take your cold water and I run that through a line through the middle of the gas, remember the second law of thermodynamics? Hot goes to cold. What's going to happen to the cold water? It's going to get hot. And so as the cold water gets hot, we're now transferring the heat into the cold water. We got hot water. So I can heat your water, and I can heat your house, unless, of course, you want to keep your house hotter than 250 degrees Fahrenheit, in which case I can't do much for you. The flesh will be melting off your bones anyway, so probably won't be very comfortable. Now, so, in essence then, we can heat your house in hot water from energy we sucked out of a snowstorm in the middle of the night. Next slide, Tommy. The best part about the heat pump that I developed is that it was the most efficient heating system in the world. Bar nothing. Now, we did that when? We did that in 1974. Is this new news? No, this is real old news. This has been out there for 20 years. We've been doing this. Thousands of customers across America have used these and have proven all of the statistics and all the data that we say. And by the way, uncontested, I developed the most efficient heating system in the world today. There's no one that's ever contested that statement or that claim, other than 2 times when it was contested in court and we won both times. Now, right here is the most efficient, the best part of that system, and that is its efficiency, the performance coefficient. The efficiency of our unit compared to other electric units, I'll go through real quickly. If you've got an electric heater, like do you have an electric hot water heater? If you do, you got a resistor, electric resistor. You put 1 unit of electricity in, how much heat can you get back out? 1 if you're really lucky, probably less than 1, but you cannot get more energy out of a mechanical device than you put into it. You can't. So you cannot get more energy from a mechanical device than you put into that mechanical device. I don't know of any exceptions to that at all. And so if you've got a mechanical device there, you put 1 in, how much can you get back out? 1. 1 in, 1 out, that's it. With a conventional heat pump, the heat pump that General Electric, Westinghouse, Borg Warner, Trane, Carrier huge corporations make. They make an air-to-air heat pump. They've been doing it for a long, long time. They did it before we came along with this one. And they're the leaders in the industry. You know why? Because they sell more than anyone else. They got a $5 billion industry, and they're the leaders in the industry. Now, with their heat pump, if you put 1 unit of electricity into the compressor, one goes into the compressor, you will get 2 units of heat out into your house. So you put 1 unit of electricity in the compressor, 2 units of heat into the house. Did that heat come from the compressor or the action of the compressor? Did the compressor create that energy? No, it did not, because energy cannot be created or destroyed. That compressor merely took impractical energy that came from the environment, made it useful, and put it into your house. Now, you're getting 2 units of heat in, putting 1 unit of electricity into the compressor. It's not over unity, for those who think it may be, because the energy's coming from the outside of the house, the environment, not the compressor. And so, call GE, call BorgWarner, call any of these big Fortune 500 companies and say, hey, you're getting 2 units of heat in the house for every 1 unit of electricity you put into your compressor, and they're saying, yes, you do. Okay, now that's the average for an air-to-air heat pump. Under ideal conditions, you might get 4 out for one, but that'll only be for a short period of time. Then along came the super solar heat pump, the one that I developed. Now the one that I developed, if you put 1 unit of electricity into the compressor, same compressor they use, 1 unit of electricity in, you get 6 units of heat out. Now, which one's more good? 2 out or 6 out? You still have to pay for 1 in. Wouldn't you rather get 6 of them out? And so it's not a real contest here, ladies and gentlemen. And by the way, it never has been a contest. And by the way, this has been proven time after time after time across the whole country. No one can argue with me about any of this stuff. This is a fact. I developed the most efficient heat pump in the world today. Now, you may be sitting there thinking, now wait a minute. This guy came along and developed something better than anything GE, BorgWarner, Westinghouse train carrier with their $100 million a year research teams came up with. And the fact of the matter is, yes indeed, I did. That's true. Now, but it's not anything that they hadn't already thought of, I believe. I believe that I'm just the first guy that came along with it that wasn't part of the good old boy network. And so I wasn't in the program. And so there was no benefit for me to not tell everybody about it, because it was to my advantage to tell everyone I knew about it. Now, here was the secret to my success. You might be going, wait a minute, this guy must be really smart. If I did something GE didn't do, I'd have to be pretty smart. And so the secret to my success is, number one, I want to give you my credentials before we go any further. I have never, ever had a refrigeration course in my life. I've never had an advanced science course, never had an advanced mathematics course. I flunked mathematics in high school, of all places. Okay? So I thought I ought to tell you my credentials. And the secret to my success is, it was a complete, total accident. Matter of fact, if you go down the road and you listen to me on the CD, my call sign is Mr. Magoo. Okay? I earned that name. Now, so therefore, this was an accident. This is something that we just did, and we had no idea what we were doing at the time. I don't have time to tell you the whole story. If you want the story, you can get that, getting videotapes and stuff, and get all kinds of information that can give you that story. Next slide, Tommy. Now, I want to just show you one piece of data, because I have to establish something clearly, because later I'm going to use this same technology in order to show you how to make electricity. And so I'm going to need to rely on this to get back here. So I'm going to show you one piece of data, but there's lots and lots and lots of data. All of it is independent test data. Now, this data right here is on a unit that we did, and the test was done on 1/1983, January 10th, 1983. Is January one of the coldest months of the year? January, February, it gets pretty cold around January, doesn't it? Now, this test was done in Minneapolis, Minnesota. Does it get a little bit cold in Minneapolis, Minnesota? It gets really cold in Minneapolis. In January, Minneapolis in January is a cold place. Now this is one of the coldest climates in the entire country in one of the coldest months of the year. So I just want you to see the setting for this data. Over here we got the coefficient of performance, COP, and if we go down this line, over there we got 4.63. That means every time we're putting 1 unit of electricity in, we're getting 4 out. If we go to the bottom, we get 5.26 for the average for January. 5 units of energy out for every 1 unit of electricity going in the coldest month of the year, the coldest climate of America. Do you see why we say we can get an average of 6 to 1 easily anywhere in the country? Because on hot days you get even better. And so we can easily get 6 to 1 with this heat pump. Now, we're going to come over here now, we're going to test this heat pump. It's been cooking for a little while. I need one volunteer from the audience. Anybody? Okay, you're the first one I saw, so you can come on up. Okay, you're just going to have to get somebody else's copy of you on tape here. All right. Now, so what's your name?
Shane.
Okay, Shane. Now, Shane's going to go over here, and first thing I want you to do, Shane, is touch that panel. Now, when you touch the panel, tell me, is it cold?
Yeah, it feels good.
Yeah, it feels good. Okay. Is that the coldest thing in the room, you think? Oh, yeah. Okay. Now, so it's the coldest thing in the room, and hot goes to cold, and so the heat is going into that water over there. Put your hand in the water there, Shane. Is the water warm?
Hot.
It's hot. Okay. So the water's hot from the energy we took out of this room here. Now, come over here to the compressor. Feel the line going into the compressor. It's cold. Then feel the line going out of the compressor. Be careful because it's very hot. You can burn your hand there. So it's cold going in, hot going out, right? Okay, thank you, Shane. All right, now, so we're actually taking the energy out of this room and we're making hot water. What could you demonstrate if you had another kind of solar system? Nothing. In this room, what would you be able to demonstrate? There's no sun. Now, so in essence, that was the most efficient heating system in the world. It still is. Well established, been out there for 2 decades, thousands of customers nationwide. I got a little bit crazy when I developed that because it was very good to me. And I became worth an awful lot of money in a big hurry. In about 18 months, my net worth grew to about $50 million. And that can get you kind of crazy. I got to the point where I decided, hey, I believe I can use that unit, since it's the most efficient heating system in the world, to make electricity. Wouldn't it be neat if I could use that unit to make electricity? I could put it on all the homes in America, and I could offer the American people an alternative to the electric grid system. Now, that was my goal. I'm an American. I love the country that we live in. As a matter of fact, my ancestor, Richard Henry Lee, my name is Dennis Lee, called for the America's Declaration of Independence. And so I think it's fitting that I'd be calling for America's Declaration of Energy Independence. Anyway, so I'm really happy to be doing that. However, I'm kind of enthusiastic about my America and about the Constitution of the United States. And I said, now we live in a republic, and in our republic we have a form of economy called the free enterprise system. And the free enterprise system is kind of our way of life. And I was sitting there looking at a monopoly called the electric company going, what's wrong with this picture? It's supposed to be a free enterprise system, healthy, open competition, but these people have no competitor at all. They have a monopoly. Now, a monopoly to me doesn't fit into our way of life. And so I said, maybe I can use the world's most efficient heating system, and I can give the electric company a competitor, and that's what I can do for my country people in the United States of America. Because you see, if you're dependent upon the electric company for your electricity, you're dependent upon somebody for something very important to life. Have you ever been without electricity? Yeah, and it's almost scary. You're standing there for 24 hours going, get it back on, because you're starting to think, hey, this isn't funny anymore. Because your food is spoiling, you got no lights, you got no energy, you got no power, you got no heat, you got nothing. And so that's somebody exercising an awful lot of control over you. And in our country, I think that's unhealthy. For all of the people to be dependent upon some centralized organization is a very unhealthy thing to a free enterprise and to a republic way of life. So I said, well, what I could do to write that, would be if I came along and produced an electric system that you could put on your house and be totally energy independent of anybody else. So that became my goal, ladies and gentlemen. My goal was that. Now, my goal was not to make free electricity. That was not my goal. I didn't care if you had to pay for electricity. My problem wasn't that you had to pay for it. My problem was that you had to be dependent upon somebody else for that source of energy, and that gave them too much control over your life. And so I set out to give you an alternative to that. That was the goal. Now, in order to do that, I first had to find out how they make electricity. So in order for you to understand it, let me first show you how they make electricity. Next slide, Tommy. Now, your electric company, your existing electric company, when it makes electricity, they take a boiler, they stick water inside the boiler, and they heat that water up. Water boils at what temperature? 212 degrees Fahrenheit. So if we put water in there and it boils at 212 degrees Fahrenheit, and we put fire on that using fossil fuels or radioactive isotopes because we have to get high temperatures, and we get a temperature of 1,000 degrees Fahrenheit, will the water boil at 1,000 degrees Fahrenheit? Of course it will. It's so above its boiling point, what else will happen to the water? It'll build into super steam. You'll get some really high pressures out of that steam. So you'll not just get steam, you'll get high pressure steam in here. Then all you have to do is turn a nozzle, let that high pressure steam escape out of here, and it hits the blades of a turbine, just like water going through a water wheel or blowing on a pinwheel. And as that pressure hits against the paddle there, won't that paddle start turning? Yes, it will. And as it starts turning, the little shaft that it's connected to will start rotating. Now, here's the secret. Anytime you have a rotating shaft, you can hook it up to a generator and produce electricity. All you need is a rotating shaft. You can make electricity. So then they make the electricity, and on the outlet side, the steam has to come out, and the steam can only go through this process one time. You can't run it back in again and again and again. It can only go through once. Now, when you put 3 units of heat over here into making this steam, you will get 1 unit of electricity. Call your electric company and ask them. They will tell you they're 1/3 efficient. That means 3 in, 1 becomes electricity, 1/3. The other 2 units of heat, by the way, that you put in the boiler over here, those get lost in this mechanical device, but half of them get thrown away over here in a thing they call the condenser. So they throw the water in the boiler so they can get the steam, and then they throw the heat away on the other side. Sounded pretty extravagant to me. Why are we throwing all that heat away? Now, if they don't throw the heat away, by the way, and it's steam, they can't get it back into water to run it back in to do it again. This is a closed-loop system, and if you don't take the heat out, you can't turn it back into water, and it won't run back in the unit. It'll go through once, and that's it. It'll sit there, and you won't get any more energy. Now, one thing everybody has to understand to make energy, you got to have a high temperature going to a low temperature. You got to have a high pressure going to a low pressure. One that all of you guys understand is if you're going to roll a rock down a hill, you need a hill. Okay, it won't work too good out there on a level plane. Try to roll a rock on a level floor. Won't roll too good. But if you've got a hill, it'll go from the high point to the low point. So you're always going in a mechanical device from a high point to a low point. And so they need the high energy, the high heat over here, the high pressure steam. But if they don't create a low point over here, nothing will happen. Now, another example of that is your car. In your car engine, you're making gas. The gas is then giving you the push on the pistons to give you the power. And then on the outlet side, what do you have? An exhaust. And so you're just throwing the gas away. So in your car, that's an open loop system. It's the good neighbor plan. Just throw your gas away, let the neighbor deal with that. Okay? Now, so in essence, if you take a potato and you stick a potato on the tail end of that exhaust pipe, will the car run? Won't run at all. If you don't have the low side relative to the high side, you can't get power, period. So you have to create that low side. Now, in this case, the only way they can do it, since they don't want to dump all this steam out against the countryside, be pretty extravagant, throwing all that water away and throwing away all that steam and maybe burn people. And so they got to close loop this thing. And so they've got to have a condenser over here, and they bring cold water in, and they take the heat out, and they cool that down through the pipes. That's how they do it. Now, I got the idea, well, if I got the most efficient heating system in the world, I can put the heat in here and I can supply this side pretty cheap. It's pretty economical. But wait a minute, what can I do here? Because if I put water in there, water boils at 212, and the hottest temperature I can get out of my unit is 250. What can I do with water at 250 degrees? Not much more than just boil it. So would I get high pressure? No, I wouldn't. I racked my brains, I racked a bunch of other people's brains. I had money, I bought brainiacs, and I racked their brains, and none of us could figure out how to use this little system here to do that. One day I went to sleep. In the middle of the sleep, now some people think I'm crazy for even telling this story, but you see, we have to give honor where honor is due. In the middle of my sleep, God came to me and He gave me the answer. So the vision came from God. And God came to me and He said, boy, He said, son, I love you, but man, you sure are stupid. And my God and I got that kind of relationship. We can talk to each other like that. He can talk to me like that. I don't talk to him like that. Well, I have no reason to. Anyway, so He says, look, get a pencil, get a piece of paper, write this down, because if you don't, you'll forget it, sure as the world. He knows me, in other words. And He started explaining to me how I could make that happen. Now, all of us couldn't figure it out, but all of a sudden there it was, clear as day, and this is when I realized how stupid I really was. You know, you get worth $50 million, you start thinking maybe you're smart. Okay? Anyway, over here, if I take this little chamber, and instead of taking water and throwing water in that chamber, why don't I take a refrigerant that boils at 100 degrees below zero? I could pick it up in any counter anywhere in the United States of America, in your refrigeration supply house. So if I put something in there that boils at 100 degrees below zero, and I only can get 250 above out of my heating system, wouldn't 250 degrees above zero get something that boils at 100 below zero pretty exciting? Sure it would. Wouldn't it build up a high head of steam? Sure it would. And by the way, for those technical people, pressure is pressure is pressure is pressure is pressure is pressure. Pressure is pressure. PSI is PSI. Pounds per square inch is pounds per square inch. It doesn't matter what you got that's creating the pressure. Pressure is pressure. And so when that pressure pushes against the blades of a turbine, it will turn the blades of a turbine and produce electricity. Next slide, Tommy. So God in my sleep gave me the answer to that. And it was, take your panels, take the energy from the air, put them down into a compressor. Now the compressor uses 1 unit of electricity to give me 6 units of heat back into the boiler. 6 to 1. I can do 5 to 1 in Minneapolis in January, so that's the average, 6 to 1. If I put 6 units of heat in the boiler and I have something in this boiler that boils at 100 degrees below zero, it's going to get all excited. And so if I'm putting 6 units of heat in there, if I can convert 1/3 of them to electricity like the electric company does, what's 1/3 of 6? 2. That meant that I could make 2 units of electricity with the 6 units of heat I got from the environment. And by the way, could I cool it down over here? I asked God that question and He looked at me again like, boy, what have you been doing with these refrigerants if not making hot water? I said, right, got it, Lord, got it. Anyway, so of course I could cool it down. So I cool it down over on this side. So in essence, if I can convert 1/3 of that to electricity, 1/3 of 6 is 2. Couldn't I take one of those 2 units of electricity I just got, take that one right there, put it right back into the compressor, and get 6 more units of heat from the environment? All it takes is a unit of electricity to get 6 units of heat. When I put 6 units of heat over here, if I can convert 1/3 of them to electricity, 1/3 of 6 is 2. Put one of these back in, get 6 more, and 1/3 of 6 is 2. Put one of them back in, get 6, convert 1/3 of them to electricity, get 2 more. Every time I go around that horn, this one right here is free. Well, I hadn't counted on anything like this. I mean, I know God loves me, but I didn't think He was going to bless me like this. And so this was an incredible vision for me. I thought, wow, I could even make free electricity. And that was quite a revelation for me, believe me. Next slide, Tommy. We went out and we built one of these units. It's a low temperature phase change generator. This is not an artist's conception. It's a real life contraption. Right down here we had a boiler. would take 200-degree heat source and throw it into the boiler. The gas would get all excited. As the gas gets excited, what is gravity to gas? Up. And so it rises up past this constrained vane machine here. As it does, the vanes turn. As the vanes turn, they rotate that generator, and that generator just sits there and make 5 kW of electricity. And then the gas would come up to the top to the condenser. And this situation is sitting out there next to a lake, and there was water coming in from the lake, and water temperature is 55 degrees. And so we have the low side cooling it down, the high side at 200 degrees. And as long as we kept the 200-degree heat source coming and the 55-degree cold source coming, guess what? It would sit there and produce electricity all day long, all night long, all year long. As long as you have the heat and the cold, it just sit there and run and produce electricity. Now, we did not prove that in a court of law. In a court of law, all we wound up proving was we had witnesses who came, who had watched this thing run, who said to the judge, they said, well, Your Honor, we only watched it for 2 or 3 hours because after that we got tired of watching it, so we don't know if it ran all day long or not. But for 2 or 3 hours it sat there running for 3 solid hours, making electricity. So, in essence, ladies and gentlemen, as long as you got the heat, as long as you got the cold, you can produce electricity. Now, the problem that we ran into here, there was a flaw in this system, and I want to relate that to you. If you came here today and you're a physicist or something and you're a technical person, you're saying, now wait a minute, no such thing as perpetual motion machine. Oh yeah. Number one, explain to me why the Earth, the biggest mass I've ever seen in my entire life or made contact with in my entire life, is flying through the air at 78,000 miles an hour, and why it's been doing it since Alley-oop was bashing people over the head, and it'll continue doing it when civilization disappears and Alley-oop is once again bashing people over the head. Could somebody explain to me what that energy source is that's taking the biggest mass you've ever made contact with in your life and flying it faster than any device we've ever made? Mankind's never built a mechanical device that can go 78,000 miles an hour. Anyway, I'm getting off the track. So, we all know that there's no perpetual motion machines, but in this thing right here, your car, by the way, is a perpetual motion machine if you keep gas in it all the time. Okay, so as long as you got a perpetual energy source, you can have a machine that's running until it breaks. And then you fix it and it'll run again. So there always has to be an energy source, however. Now our problem that we have right here, if you're technical and you came here and said, well, wait a minute, this can't be, you're right. Because we had to have that cold side, we had to have the lake. Now if I was going to take this unit and put it on the houses of everybody in America, how many people in here have a lake? Got a lake on your property? Just a few. So you see all the people in here that don't have a lake on their property, I couldn't make electricity for you. I could make electricity for all the guys with a lake on their property. And so this was a problem. The condenser over there, that was a problem. You got to have some way of cooling that thing back down again. That was a major problem. So what could I do with this unit right here? Well, I could have made a lot of money, but I'd already made a lot of money. I could make more money. More money would have been easy. Because what I could do is I could convert everybody to have a lake on their property, number one. But number two, how about farmers? I don't know a farmer that has a cabbage crop that doesn't have a lake on his property. You know why? He's got a lake coming through the ground. It might be underground, but it's called a well. And he's running water across that field, and he's running a whole lake of water to that cabbage or rutabagas, isn't he, or corn? He's running a lake of water there. Now imagine if I had the condenser on this side where the water was coming out of the ground being the cooling side. I could take the energy out of the air for the high side. I could literally not only make him electricity, but forget the electricity, I could power the pump that was driving the water out of the ground. So ladies and gentlemen, I'm going to show you a device. The device that I'm going to show you is a pump that will pump water for farmers for free. And it's going to be on the television set. And we will show you that as long as the farmer has to pump the water can be the cold side. We can take the energy out of the air for the high side, and we can pump water for farmers for free. How many farmers would enjoy that? That would have been a pretty big seller. Could go all the way across America selling that. The other thing that we could do with this technology, the way it was right there, that was we could go to hotels. Now this hotel right here, do they have a lake? Yeah, they got a lake. You know what their lake is? Forget the swimming pool. All the people that get up in the morning that want to take a shower. How much cold water does a place like this run through in the course of a day? Lots of cold water. If all that cold water went through the cooling side of my low temperature phase change generator, I could take the energy from the air, cool it down with all the water for the showers, and I can make free electricity for this hotel right here. Sure I could. And I'm going to next show you that we can do that in a process that we got in our research facility. So we're going to go to the television, we're going to watch 2 pieces of film. One is a pump that will pump water for free. The other one is a process that will make electricity for hotels, linen supply houses, or anybody that uses large volumes of hot water, also for free. Okay, we ready, Tommy? Let's go.
Okay, we got to heat up the boiler first. Then we just turn it on, let the gas escape, just get what you need there, and turn it on, let the gas escape. That'll turn the cylinder, get the linear motion. The sprats will do the rotation. This will start turning. That right there is the compressor that will also be driving. And then this is the pump that will be pumping the water. And then that right down there, just be a bonus, will be also like some light bulbs. We have to blame on lights. Okay? Are we pumping water or what? Just like the light bulb. Plug in the light bulb. What's wrong? You can't get it plugged in?
That's my assistant, Michael Hall. You might notice him hiding in the corner there.
Oh, well. Is it still pumping water or am I crazy? All right?
We only let 3 light bulbs at demonstration because 2 of them were burned out.
Michael, you got a broken plug. Okay, well, Jeff can't do much about the plug. Sorry about the lights this way. Last time we were at it was all, we lit up all of them and just kept lighting them, and this thing just keeps pumping water. But see, it doesn't make an awful lot of noise, does it? Now, if we have a driver and we're driving a pump to pump this water, where else should we drive? Obviously,
Drive a
we're driving
generator.
a pump.
Couldn't we drive a generator? Now this is the unit at our research lab. He's going to light all those light bulbs up. He's going back now to plug in the light bulbs, and when he plugs it in, it's really loud. And when he plugs it in, you're going to see it plug in on that generator, and the generator will lock down and the noise will diminish. See that? Now, this one here is only lighting 20 light bulbs. It's a demonstration model it's actually an R&D model that we're using in research. In Philadelphia, Pennsylvania, if you come to that show, we're going to show you this completely finished, ready to be put into hotels all across America to produce free electricity for all the big commercial hot water users. So we are online, we are ready to do that. We will be putting free electricity into hotel chains all across the United States of America as of the end of this summer. After the 23rd of September, when we declare energy independence, the first thing we will do is put free electricity into all of the commercial establishments first. We also will be, of course, putting something down there to pump all the water for the farmers for free, because somebody's got to do something for the farmers in this country anyway. Now, well, there's a lot more we can do for farmers in this country too. Some other things that can grow you about 3 times the amount of crops, about 3 times as big. And so if you're a farmer, believe me, you definitely want to get in touch with our company. Now, so that was where we were, and that was what we were interested in. But you see, that wasn't the goal. Remember what my goal was. My goal, I set out, I'd already done what I guess you could call success. I mean, I was worth $50 million. I'd done fairly well for myself, pretty young guy at that time. And I set out then to do something for my country, do something for my country persons. And so, in essence, that wasn't good enough because we had a problem. And the problem was, if you didn't have the cold water, you couldn't make electricity. Now, we had another problem. And the other problem I'll confess to you right now, and if you're a technical person, you'll say, ah, boy. You might have been sitting next to a technical person that said, this guy's forgotten all about the Carnot cycle. Now, if you are technical and you know what I'm talking about, the Carnot cycle, And if you're not technical and you don't know what I'm talking about, don't worry, because I'm going to tell you what I'm talking about. The Carnot cycle is a formula that is used to determine how much mechanical or heat energy can be converted to mechanical energy. How much heat energy can get converted to mechanical energy. This formula will tell you. And it relates primarily, whenever you're using heat, to temperature gradient. And so when the electric company makes their hot water and they produce electricity with steam, they have 1,000 degrees Fahrenheit. That's their high temperature. Their low temperature is 55-degree ground temperature. So they're going from 1,000 to 55. Remember that? I showed you that in the beginning. Now, they can convert 1/3 of their heat to mechanical energy or electricity. Now, whenever we're doing this, we don't have 1,000 degrees. We already told you that. We only have 250 degrees. The Carnot formula says the bigger the difference between the high temperature and the low temperature, the more that can be converted to electrical energy. So when they're at 1,000 to 55, they can get 1/3 converted. But if you're only at 250 to 55, if you calculate the Carnot formula, you'll see that we can only get about 23% converted. So we wouldn't be 1/3 efficiency. We would only be about 1/4. Now let's go back and play the game again. If I put 6 units of heat energy in, what's 25% of 6? 1.5. And you didn't even have a calculator. I can't even think since I've been carrying a calculator around. That's great. So 1.5. Now that means that if I could take 6 units of heat from the environment, I could make 1.5 units of electricity. And so when I discovered this, I said, well, no problem, I'll just build it twice as big. I put 1 back in, I get 1/2 every time I go around, that's free. Then my technical people started laughing and they said, Dennis, you never give up, do you? They said, well, you got a problem, you got another problem, brother. And here's your other problem. Your other problem is, what does average mean? What does average mean? Average means half the time you're above that, half the time you're below that. So if I've got a 6-to-1 COP average, that means that half the time I'm 6 or better, half the time I'm 6 or worse. Well, I can't afford to get any worse, because at 4-to-1, I can't do anything. I can't make any free electricity at all. And so that meant that half the time I could make free electricity, half the time I could not. Well, for farmers it'd be fine, because when do they need the water for the field anyway? In the summer, so I get the high efficiencies anyway. And for the hotels and stuff, they'd be happy to get all the free electricity they can get, anytime they can get it. So I still could have made plenty of money, but the problem that I had was, if I had to have that condenser, and at the low temperatures I was operating at, I could not. If you're here and you're here to say, he can't do that, you're right. I could not make free electricity all across the country for everybody. Couldn't do it. Now, lucky for me, and even more lucky for you, that I ran into a gentleman named Dr. Victor Fisher. Now, the reason why that's so good is because Dr. Victor Fisher, a genius if ever I've met one, Dr. Victor Fisher had worked out the details on the most efficient heat engine in the world today. This man created a whole new engine cycle. Now, if you're here technical, then pay attention to what I'm going to say next, because this engine cycle can operate an engine in a closed loop, not an open loop engine, no exhaust, in a closed loop with no condenser at all. No condenser. Now that's impossible. It's impossible to operate an engine in a closed loop with no condenser. That's impossible. Well, not really, but, and I'll show you another reason why I say that. But for right now, it is incredible. Now, I'm going to explain to you a device over here called the Fisher heat engine. Now, this is merely being utilized to show you the concept of the Fisher heat engine. And you know what I'm going to do, Mike? I think I'm going to turn that off, because the guys filming won't be able to compete with that, and they can get probably a better close-up of it than without it. Now, the Fisher heat engine. Now, by the way, let me just set this up real quickly. There is no technical person. If you're an engineer, guess what? You have got to have studied the steam engine. There's no technical person that has never studied the steam engine. All technical people have studied the steam engine. However, what Dr. Fisher did with this little technology right here is Dr. Fisher proved that they built the steam engine wrong. Now, when was the steam engine built? 350 years ago. It probably had a greater effect on humanity than any other thing in our entire history. The steam engine caused the great industrial revolution. For Dr. Fisher to come along 350 years later and prove that they built the steam engine wrong is no small matter here. Because every technical people in the world has studied the steam engine. So am I saying that if Dr. Fisher proved they built the steam engine wrong, that every technical person in the world that studied the steam engine and didn't see that they had built it wrong had missed something? And I'm saying yes, indeed. All the technical people in the world that have ever studied the steam engine have missed something. Now, if you are indeed technical here, and you've studied the steam engine, then for that reason alone, you need to see what I'm talking about as I explain how the Fisher engine works. Now, this is not an Otto cycle, not a Wankel cycle, not a Stirling cycle. This is a Fisher cycle engine. There is no engine cycle like it in the world today. I patented this and paid a lot of money for the patent for it with 23 claims that prove that they built the steam engine wrong. Let me get into proving to you that they built the steam engine wrong. Now, I'm not going to explain this engine to you. I'm going to let you explain this engine to me. Okay, so you guys can explain the engine, so get ready. I'm going to do this by asking you a series of questions. You're going to give me the answers, and as you give me the answers, you're going to be explaining how this engine cycle works. Now, we're going to demonstrate it later over here, but right here we're just going to use this cylinder to prove to you, to show you how it goes. Now, right here we have a cylinder, we got a piston inside of it, piston's made to travel, and the piston comes up here, but it's not all the way back home. If you look at this as a close-up, you will see that the piston is back about that far from the end. So it's not all the way back. If it was all the way back, then this wouldn't be right. So this amount of space right here that we have before that engine goes all the way back is the exact amount of volume that this liquid occupies. So this liquid, if this liquid was poured into this funnel, would exactly occupy the space that is left on the back end of the travel of that piston. Now, so we don't want it to be all the way back, because what we're going to do is we're going to use a liquid and we're going to inject that liquid into the engine for the cycle. Now, this liquid that we're using right here can be any liquid at all. What liquid can we use for the engine? Any liquid. Any liquid at all. If it has a boiling point and a critical temperature, in other words, if it's a liquid, we can use it. We can use isobutane, we can use ammonia, we can use isopropyl alcohol, we can use anything at all. We can use water, we could even use liquid peanut butter. If we could figure out a way to liquefy peanut butter, we could use it. So we're going to put a liquid into this container here, and the liquid that we're going to use for our illustration is going to be water, because that's what you're familiar with, and I'm going to ask you some questions about it. Now, water boils at 212 degrees Fahrenheit, okay. Now, we're going to take this water, we're going to put it in this little vessel. It's exactly the size of the volume that we got, the space we got on the back end of that piston. Now, the first thing that we're going to do is we're going to fill this vessel all the way to the top with water. So it's completely filled with water all the way to the top. And let's imagine that it's a pressurized vessel, and we're going to put heat on this vessel. Now, when I run the heat of this vessel full of water all the way up to 212 degrees Fahrenheit, what's going to happen to this water? Is it going to boil? Is it going to expand?
No.
Okay, we got a couple of people that say no. Most people say yes. However, in this case, the people who say no are absolutely right, and the people who say yes are wrong. Because if it's filled all the way up to the top, and there's no room for it to expand, it can't expand. So it won't boil, it won't expand, because it's totally, absolutely full. So if it's completely full and it's 212, it's not going to expand. Then if we run the temperature up to 300 degrees Fahrenheit, will it expand? No, because it's completely full. It has no room to boil. So this water will not boil because it can't boil, because it has no room to expand. If we run the temperature up to 400 degrees, it still will not boil. So we've got water, it's in a vessel, and it's 400 degrees, it's not boiled, but it still is water. Now, at 500 degrees, it still will not expand, but at 500 degrees, imagine how excited the molecules are in this little vessel. Can you imagine that? Those molecules are 500 degrees. Do they want to boil? They want to boil like they never wanted to boil in their entire existence. They want to be steam, and they want to be steam right now. However, they can't because there's no room for them to boil, to expand. And if I kick the temperature up to 600 degrees Fahrenheit, those little molecules are running around in there like crazy. I mean, they are taking up everybody in their space. They're on each other's toes. This is like a can of sardines here. These things are packed in here so tight, they're so active, it's kind of like two teenagers trying to share a room. Okay? You're on my space, get off my space. Now, if I run the temperature up to 600 degrees, guess what else? This water right here, if it was 600 degrees Fahrenheit, this would be the first time in its entire existence it was ever 600 degrees Fahrenheit and still water. This would be the first time it ever hit that, it ever achieved that. It's still water and it's 600 degrees Fahrenheit. Why? Because normally it would have evaporated long ago. No matter how many times it came or went, it still would have been, it never would have gotten 600 degrees and still been a liquid. Now, if I crank the temperature here up to 700 degrees, at 700 degrees, I will stop. And the reason why is because mercy triumphs over judgment. No, the reason is because the critical temperature is 720, and when I get to 720, I don't ever want to get hotter than 700 degrees. Now, so I've got water in here, it's excited, it wants to boil like crazy at 700 degrees Fahrenheit. It's got tremendous amounts of energy in it. The molecules are bouncing around like crazy, and all of a sudden what I'm going to do is, instead of pouring it, I am going to immediately inject it right into the back end of this piston. I'll help it along a little bit, but if you saw that, that's blue, the water's blue. You see that space there? Now, the amount of water we had in here that was 700 degrees Fahrenheit has just now occupied this space on the back end of that piston. We didn't pour it in, we would have taken a big rotating cam around and injected it right into the back end of the piston. As we inject that water into the back end of the piston's got a flat surface, so we're going to get a hydraulic effect across that piston. And what do you think is going to happen when the prime mover, water that's 700 degrees that wants to boil so bad it can't stand it, hits the movable object, a piston that was made to move? What's going to happen? The water's going to make it move, right? And so the very first thing that's going to happen here is as the water hits this piston, the piston's going to move. So the water's going to push that piston. Now, it doesn't matter how much it pushes the piston, however much it pushes the piston, there's going to be space created. Do you see this? Space is being created here now. So we've got that much liquid at the bottom, and we've now got this much space at the top. Now, why did the water not boil? The water didn't boil because there was no space. Now, the water didn't boil because there's no space, but right now the water is there and there's space. What's going to happen to the water? It is going to right now flash into steam. Now, it isn't just plain old steam. This is a steam explosion. It's going to explode into steam. As it explodes into steam, it is going to start doing what to the piston? The steam is going to start pushing the piston. Now, as it pushes the piston, it's like if I shouted fire and there was one door back there and all of us wanted to get out of this room at the same time. Can you imagine how hard all of us would be trying to get to that door right there? All right? Well, it's the same thing with all these water molecules. We got all the water molecules in here, and every one of them want to become steam so bad they've never wanted to become steam this bad in their existence, and they now want to get down this thing and relieve this pressure and become steam. And so right now we get a new kind of steam. We call it Fischer steam because these molecules are the size of grapefruits. And they're going down this piston, and I mean there is some power here. So we have a steam explosion, and now we're driving the piston. Now when we drive the piston, can we get work out of the back end of this? Of course, that's what pistons are for. This arm here can be turning a wheel, doing all kinds of things, giving us power or work. We're also going to get a heat loss on the cylinder, and we're also going to get friction inside the cylinder. So we got friction, heat loss, and work. So what's happening to the temperature of the fluid? We're losing some of the heat to work, some of the heat to heat loss, some of the heat to friction. Isn't that fluid getting cooler? So it's cooling down. So as it's converting to steam, it's now pushing against this, and we are cooling down the fluid. Also, as it's pushing the wheel, look what's happening to the volume there. Now you see one thing the electric company did wrong. What did the electric company do wrong? Well, they took water and they put it in a vessel bigger than the water and let it become steam and use the steam. In our case, we put it in a vessel that had no room to expand and let it become liquid so that it would flash into steam in an explosion of steam. We get all that power all at one time. That power is then now going to push against that wheel there. But the second thing the electric company does wrong is they start that steam coming, and then they just keep the steam a-coming. They're standing there going, okay, Russ, just keep the steam a-coming. And as the steam is just rolling in there against the wheel, they're just continuing to throw more and more steam in there and getting work against that wheel, against that piston. Well, in this particular case, this is it. One shot does the whole cycle. We put one shot of water in there, we get an explosion, and as it explodes, it's then turning into steam. As it's pushing against this wheel, it's increasing the volume. As we increase the volume, what happens to the pressure? Volume increases, pressure decreases. The formula is PV equals nRT for technical people. Pressure times volume is power. As you increase the volume, you decrease the pressure. So as we're increasing the volume by moving this wheel, the pressure is decreasing inside of here, and the boiling point is changing, by the way. And guess what's happening? As we're continuing to increase that, the steam is rolling and pushing against the wheel, and we're getting all this power and drive. The volume is increasing, the pressure is decreasing, and now we're approaching the point to where we're almost at the end of the cycle. There's no more liquid in there. The volume is so great that the boiling point has changed, and the liquid is now cooler than its boiling point. What happens when you've got steam that is cooler than its boiling point? Becomes a liquid. The definition of a gas is hotter than the boiling point. The definition of a liquid is cooler than the boiling point. So when the boiling point gets such and the temperature is decreased, have you ever heard the phrase, he just ran out of steam? Well, that's what's happening here. We're just running out of steam, and there's no more liquid going in. So when we approach the end of this cycle, if we have built this thing properly, it is now cooler than its boiling point. It becomes a liquid. And on the end of the cycle, the last stroke, it falls out the bottom in a weak fall as a liquid. Now, I got a question for you. If it comes out the bottom as a liquid, what do you need a condenser for? What do you need a condenser? You need a condenser in the other thing because you got to take that steam and turn it back into a liquid so you can put it back into the cycle again. But in this particular case, we're ready to go right back into the cycle again on the top side. So you see, in this case, you don't need a condenser. So you would have an engine that is running in a closed loop with no condenser. Now, ladies and gentlemen, let me tell you something about efficiencies here. Do you remember when I talked to you about making electricity? What do they do in the condenser? They throw 50% of all the heat they put in the boiler away. Now, if you don't throw 50% of all the heat that you put in the boiler away to get this back to a liquid, and you can put it right back into the boiler again, aren't you putting 50% of all that heat right back into the cycle? And if you are, is it hard to imagine that that engine will run at least at a 50% efficiency? So you see, if I've got an engine that needs no leg, no condenser at all, and runs at a 50% efficiency, can you see what kind of a breakthrough this is for making electricity? It means, number one, I don't have to have a lake. So if you don't have a lake on your property, it doesn't matter because we don't need a lake with this unit. And number two, if I don't have a lake, I also got the efficiencies of at least 50%. Now, what's 50% of 6? If I can get 6 units of heat, what's 50% of 6? 3. I like it a lot better on this side. No lake and 3 to 1. Getting 3 units of electricity every time I go around the horn. Turn on the next slide, Tommy. Now, this right here, ladies and gentlemen, is a Fisher engine. That is the Fisher engine. Not this whole thing, that's the Fisher engine. That engine is 6 inches in diameter and it is 13 inches long. Ladies and gentlemen, that engine right there, I spent $640,000 building that. That engine right there will fit in the glove compartment of any American-made car. Right in your glove compartment. That engine right there can be picked up with one hand, backhanded. On that engine right there, we've got 4 moving parts. 4. There's no carburetor. There's no spark plugs. That engine right there with 4 moving parts has absolutely no condenser at all and needs no exhaust at all. So if it needs no exhaust and it has no condenser, you can run that engine anywhere, and even on a car or anywhere at all, stationary or mobile. It's a very small one because it would fit right into my hand. My hand has picked it up backhanded before. If it fits in the glove compartment, surely there couldn't be any power in that engine. How much power could you get out of an engine that you put in your glove compartment? Couldn't be very much power there. Well, this is a very low RPM, high torque engine. This engine right here will put out the same power, the same horsepower, and the same torque of an 80 horsepower internal combustion engine. 80 horsepower. Can you imagine 80 horsepower in your glove compartment? Now, we didn't even think about this at the time. None of us thought about this. You get so unidirected, you just get focused on where you're going, and we're going to make free electricity, or we're going to make electricity, and we didn't even think about putting it into a car. Later on, we had that vision or that idea. But if we walked around to the front end of your car, and we took the hood on your car, and we lifted that hood up, and we looked at the engine compartment, we took that piece of junk out of there, and we threw that thing away, how much energy, how much size could we get there? If I can put 80 horsepower in your glove compartment, how many horsepower could I put in your engine compartment? Does anybody here want 2,000 horsepower? Would you like to have 2,000 horsepower? Okay, the only thing is you got to put wings on that car when you put 2,000 horsepower on it. Okay, so I mean, we didn't even realize what kind of a breakthrough we had for automobiles at the time, because we're trying to solve the problem of making electricity for people's homes. And so next slide. Now, let's put it all together. If we can take energy out of the air, using 1 unit of electricity, get 6 units of heat, put those in here, run the Fisher engine with it 50%, make 3 units of electricity, put 1 of them back, get 2 of them for your home. We can even, if you don't need them, store them so that we can take them back out of storage anytime when you got high peak demand. We can put a unit in your house to make free electricity all the time, whatever amount you needed. Next slide. Let's take a look at the amount of electricity we can make with these 2 technologies. The world's most efficient heat pump combined with the world's most efficient heat engine. When we put these 2 technologies together, if we go across this top line, it says 2 to 1 over here and 12 to 1 over there. That's our heat pump. We say 2 to 1 because we used to demonstrate it in a walk-in freezer at our research lab. We put the heat pump in a walk-in freezer, we cranked the temperature down to 20 degrees below zero, and at 20 below zero, we were taking energy out of there, making water hot enough to burn your hand from the energy we were taking out of 20 below in dead airspace, and our efficiency was 2 to 1. We proved this every weekend for an entire year. People flew from all over the world, brought their own instruments, their own technical data, and we proved it every single Saturday and let anybody put any instrument on it that they wanted to. Every Saturday we proved that for a year. So I would say that that's probably a condition worse than you're ever going to get here in this area, so we start there. And if we go to 12 to 1, we proved that in a court of law. The father of the Boeing 747 airplane, a man whose life you put your life in his hands many times. This man testified in a court of law that he himself personally tested a 12 to 1 COP with our unit. He was my chief manufacturing engineer. We also have a man who built the hull design of the modern-day submarine that testified in a court of law that he also saw these efficiencies. And so we have more than proven the efficiencies, but our average efficiency of 6 to 1, if we take that line and go down that line, so we got a heat pump at 6 to 1 average, and this is the engine, the heat engine at 50%. If we draw a line between 50% for the engine, 6 to 1 for the heat pump, and where these 2 lines converge, if that's the average, then we would get 26,645. That's the number. 26,645 watts. 26,645 kilowatts of free, I don't know how else to say this. It costs absolutely no money to make this. Isn't that free? Free electricity in 1 year. So if we put the heat pump with the heat engine, you have to buy the heat pump and the heat engine, so that's not free. But they operate at no operating cost at all, driving each other from the energy that comes from the environment. Is there an energy source? Yes, there is. It's the environment. And free electricity, 26,645 kilowatts. Well, is that enough electricity for you for your home? Well, the average home in America, according to Arthur Little, major research firm, the average home in America that's all electricity uses 30,000 kilowatt hours of electricity in a year. To heat in the north or to cool in the south, 30,000. So we're 26,645 anyway, but that is per horsepower. So that's with 1 horsepower of compression, and the unit that we were building was a 4 horsepower heat pump. So if we put our 4 horsepower heat pump with a Fisher engine, multiply that times 4, now do we give you enough electricity? Over 100,000 kilowatts of free electricity in 1 year. Can you handle that? Well, surely you can. As a matter of fact, you can teach your kids a whole new trick. They can learn how to be afraid of the light instead of being afraid of the dark. You can light up the countryside and teach all the burglars a new trick. They can learn how to burglarize your house in daylight, even in the middle of the night. You got all the power you need, and what did you do to harm the environment in any way? You harmlessly suck the energy from the sun, even when the sun goes to sleep. From the sun, wind, rain, snow, sleet, and hail, free electricity to your house, literally no negative environmental impact whatsoever, doing absolutely nothing at all, using refrigerants that if you held them out here and you just threw them out here, you still couldn't hurt the ozone in any way with them. Ladies and gentlemen, that probably makes too much sense. Now, I got pretty excited with this technology because the greatest part of it is it was so practical. If I were to take an electric unit, put the heat pump with the heat engine, and put it on your house, do you have any idea what it would cost me to make one of these for your home? My cost, $2,500, my cost, and you never, ever, ever pay an electric bill again as long as you live. Can the electric company, you bet, can the electric company compete with this?
No.
How could the electric company compete with $2,500? You never pay an electric bill again. They couldn't. There's no way they could compete. How about this one? How about we come along and put it on your house for free? Ladies and gentlemen, your cost to get one of these on your house, nothing. Zero. Don't put up any money at all. However, we put on a unit that will supply 3 or 4 times as much power as you need. So you can have your power for free, but we will take the excess power that you produce and we'll sell it back over the grid system back to the electric utilities company and make money selling them 3 times as much power as they ever used to sell you. What do you think about that one? Would anybody here be interested in us putting one of these on their house totally for free, and all we get is the power that we send back to the electric company? We think so. We think this would not be a tough sell. We think that probably it'd be pretty easy to re-revolutionize or reinvent the electric companies in America. How about this? Power in the hands of the people, because the people themselves become the power plant that supplies the electricity through the grid system to all the industry. Let me tell you something. I was well on my way to the Declaration of Energy Independence, or I should say we are well on our way to that. Because, ladies and gentlemen, we did this show. We showed this to the Congress of the United States on the 5th of March. We already did this show for them on the 5th of March and started dialoguing with the Congress about reinventing the electric companies. Ultimately, they wound up not wanting to dialogue with us, but I noticed that they've changed their laws the way we wanted them to change them. And so don't be surprised if maybe something like this comes out real soon, because guess when we're going to do this? In 1996, we're going to do this. Is that this year? That's this year. When in 1996? Sometime from the moment that I'm standing here right now, and the very last day of this year at midnight, this is going to start happening all across your country. If you want to be part of that, by all means, you got a survey form, fill out that survey form, and that's what that survey form is there for. Now, this is pretty exciting news. Next slide, Tommy. Hold on that slide right there. Now, we came back and said, well, wait a minute, we got something else. Because it suddenly occurred to us, hey, why couldn't we put this in your car? There's no exhaust. And so we would be able to put this in your car, take the exhaust system off your car, and throw that piece of junk away. I wonder if that would hit the EPA standards. Probably not. You probably have to have a certain amount of exhaust, so maybe we'd have to put something on there that smoked a little bit or something. Yeah, we'd be below our quota of exhaust, so. Anyway, so now we said, wait a minute, if we put that in the car, it runs at 150 RPM with that 80 horsepower, that little one. 150 RPM is too slow for your car, and so we'd have to modify your car, modify the drivetrain and everything. And so we were starting to think about this, and one of the dealers in our network called, and he said, Mr. Lee, I've got to talk with you. I'm a race car driver. I was trying to put power. I'm always trying to figure out how to get more power in my race car. I was trying to get more power in it. I was developing something very much like the Fisher engine process. And I saw you on that television program on cable TV, and it suddenly hit me, you guys have not only got it, but we can work together on this thing, because what you seem to be missing, I have. I said, what's that? And he said, well, I believe that I can modify the Fisher concept to run in any piston engine. I believe that I have a process where I can modify any internal combustion piston engine to run on a Fisher process, and you wouldn't even need to have a new engine. Whoa! Well, I'm kind of stupid, but I'm not real stupid. And so I jumped in an airplane, flew out, and saw this young man, who was an incredible young man named Eric Brower. Now, Eric Brower and I talked for 2 days, and we designed together the idea of the Fisher-Brower cycle engine. Now, this right here is the engine that came out of that. 40 days from the time that Eric Brower and I talked, this engine was completed. Eric said, look, Mr. Lee, I will go out and prove it. And I said, fine, I'll finance it. So we paid for it, and he modified this engine right here. Now, this is a 318 Chrysler engine. It's a regular 318 Chrysler engine. If you have a V8, small V8 Chrysler engine, this is the one you got. This is the smallest V8 engine Chrysler made. Over on this side, we got the same valve cover, we got the same spark plugs. No modifications have been made to this motor, to this engine at all. On this side over here, however, we have taken the 4 cylinders, and we have modified 2 of these cylinders to a Fisher-Brower cycle. Now, we could modify all 8 cylinders, but we've only modified 2, because by modifying 2 of them, we can run it for you. If you got a V8 engine, you got 2 cylinders, you can run a V8 engine on 2 cylinders. So we've modified these 2 cylinders over here, and what we're going to do, I'm going to take my assistant David Baring, who's going to take a torque wrench right out of the packet from Sears Roebuck. This is a Sears Craftsman torque wrench, the finest. And we are going to test, well, we got to give them something too. We are going to test the torque on this engine. Now, the reason why we're going to test the torque on this engine is because if I took the engine in your car, the same engine, the same car you're driving now, you wouldn't need to buy a new car. You wouldn't need to even buy a new engine. We could just modify the same engine in the same car you're driving now to run with no gasoline at all. Would anybody in here be interested in that? Okay, now, so let's see if we can do it. But here, let me just give you another thing. If we modified that engine and you had so little power that when you set it alight, the light changed to green, but you couldn't get out of the intersection before it changed to red again, would you then want me to modify your car? No, because you see, I can already modify your car to run with no gasoline at all. All I got to do is just take the keys away from you, and it won't run, and it won't use any gas. So see, you guys want power. You don't just want to have no gasoline. You want to have the same power you had before. So we're going to test the torque on this engine after we modified it to see if we can give you any power at all once we modify your engine. So that's the reason why we've got this. Now, put the slide up, Tommy. Now, if you look over there, the bottom line there that's circled, it says hours, this one right here. If you come over to this line right here, it says 260 foot-pounds at 1,600 RPMs. Now, this engine right here, that's the engine right there. So that engine is this engine. This is the 318 Chrysler engine, smallest V8 engine Chrysler made. It says that you should get 260 foot-pounds at 1,600 RPMs. Now, we've modified this engine, and we now have modified 2 cylinders. We're going to test only 1 cylinder. So we're going to test the torque on 1 cylinder. Let me tell you very quickly how we can tell how much torque we have on all 8 cylinders if we only test 1 cylinder. First of all, in a V8 engine, there are 2 cylinders up at any one given point in time. You always got 2 cylinders up. We are going to modify all 8 cylinders because all 8 cylinders will become a power stroke. In the car you got now, half of them are a power stroke, but the other half of them are being used for compression and stuff, and so you're only getting power in 4 cylinders on an 8-cylinder engine. Now, when we modify this, we don't need that compression idea anymore. All 8 cylinders are going to be power strokes. So we got twice as many power strokes when we modify that engine. So if we test the torque in 1 cylinder all the way through its power stroke, whatever we get, we got to double it because there's 2 of them doing it. Okay? So if we got 100 foot-pounds of power, if we doubled that, it would be 200 foot-pounds of torque. So we'd have 200 foot-pounds if we only measured 100. Now, the other 6 cylinders are somewhere in their travels to compensate for them. We have to take what we get on the 2 and divide it in half. And so, in other words, if we got 100, then 3 times whatever we get is what we would have. That's what the power we'd have on all 8 cylinders. 3 times whatever we got on 1. Yeah, sure. Check out the torque wrench while you're at it. Now, also, by the way, we invite anybody to bring their own torque wrench to the next meeting. Just bring one to it, and we'll use your torque wrench, all right? Bring it unopened in the package, though. All right, now, so right here, then, we got 260 foot-pounds. Well, if we're getting 1/3 or 3 times whatever we get on 1, then 85 times 3 becomes the 260. So if we get 85 foot-pounds, if we multiply that times 3, that'll be the 260 foot-pounds torque that we normally get. Now, this up here is the biggest V8 engine Chrysler made. Now, if we put this torque wrench on here, we got 1 cylinder and it goes to 85. Show them where 85 is, David. If that little red knob goes all the way to where David's pin is, then we're getting the same power out of that engine Chrysler gets out of it burning gasoline with internal combustion process. If, however, it goes all the way over to 125, because the biggest V8 engine Chrysler made is 380 foot-pounds of torque. What's 1/3 of 380? 1/3 of 375 is 125. So if we get about 125 foot-pounds of torque where his pin is right now, if that needle goes all the way to there, we would be getting the same torque out of the smallest V8 engine modified to our concept that they get out of the biggest V8 engine Chrysler made. Okay? So we'll see. Now, that would be about 1/2 inch from the end of this thing. So we're now going to put this torque wrench on this engine. If you guys are filming, you need to do a close-up on this. And we're going to set up this test. I'm going to have my assistant hit one of these cylinders, And we are then going to see what kind of power we get on here. Now remember, if it goes about halfway across, that's 85. If it goes within an inch of the end, that's 125 foot-pounds of torque. That is the same torque of the biggest V8 engine Chrysler made. Okay, we ready to do it? You guys ready to do it? Let's go ahead and see how much power we got here. Give it to us. I love doing this. This is my favorite thing in the whole show. I love doing this. Let's see now. Let's see what we got here, guys. Now remember, if we went about halfway across the numbers, we had the same power they had. If we went within about an inch, a half an inch of the end over to here, we had the same power as the biggest V8 engine that Chrysler made. What in the world do we have way out here? What is this, anyway? Now, of course, when you get off of this, it all gets askew, and as a matter of fact, it got very askew. By the way, this presentation was sponsored by Sears Roebuck Corporation, because this is guaranteed for life. Thank you, Sears. I promoted you first. Okay, now, so how much torque is there in that engine right there? Well, we're up to the 4th model. This is only the first model that was ever done. This will be in a museum someday. The 4th unit that we have is a completed unit. If you come to Philadelphia, to the show we have there, we will have the completed unit for you in Philadelphia, the way we're going to do it in your car, because our intention is, right after the show in Philadelphia, we will begin putting this on the market, and we will modify anybody's car, anybody's tractor, anybody's truck, anybody's trailer, anything you want us to modify. If it is a piston engine, we will begin modifying that all across the United States of America, and your cars will no longer run on gasoline. Not only no exhaust, no gasoline at all. Now, how much torque will you have in this engine? Well, you saw the torque there, but actually on that same engine right there, we have calculated now, we're very close to the end of the program, and we have calculated now that you would have about 1,500 to 1,600 foot-pounds of torque. Now, by the way, the biggest semi-truck in the world runs at 1,450 foot-pounds of torque, so the smallest V8 engine Chrysler made would be able to power any semi-truck in the world. Okay? Is there a little bit of power here? Matter of fact, if you get us to modify your car, which we anticipate will cost you about $1,500 or less, if you get us to modify your car, you should think about only getting 2 to 4 or 6 of those modified. You don't want all 8 of them modified unless you are going to put wings on that automobile. All right? Now, the next thing we're going to do for you, we're going to run this engine. Now, we got 2 cylinders, so we can run the engine. When we run this engine, we've got exhaust coming out of both sides of this piston. So all we're doing here, we are proving the concept. That's what Eric built this engine for, was to prove the concept. But we are running it with CO2 in a bottle. Now, there's 2 reasons why we're using CO2. First of all, it's user-friendly, and the guys in the front will be happy about that, because if I use pentane, it would stink, and you guys wouldn't like me very much. Your wife wouldn't either when you went home, because it still stinks. Anyway, and so that's one reason. The second reason is we can get the same pressure on those pistons simulated that we are going to get when we have those pistons and we're utilizing this in a closed loop unit. So it's going to be an open loop for now. This is the first one. Took 40 days from the time we had the idea to do this. Now we've got 4 generations of this. The one you see in Philadelphia will be a closed loop. It won't be making any noise at all. This one's exhausting, and so you're going to hear noise. So you'll hear noise because there is exhaust in this one. But the CO2 is going to be coming out of these exhaust ports, and it's going to come out white as snow. So when you see this, it's going to be coming out of there white. That means it is condensing in the cylinders and coming out white. Okay, so we're going to run it for you now, very carefully, because we got so much power here, we have to go slowly with it, because this thing has a tendency to want to walk right off of this engine mount. We got it all bolted down, but there's so much power here. That's why Big Mike is up here now. He saved this one time. It already started trying to walk off the engine mount. So we ready now? Everybody ready? We're going to turn it on. Let's go for it. Okay, now let me just tell you very quickly some of the most salient points. Number one, when we are taking this liquid to explode on the top end of those pistons, we are still getting a tremendous amount of power, but the power that we're getting is going against that head, and we're getting a more even pressure all the way through that stroke. It's not like the power stroke you get in your car. You burn that, you get the explosion, you try to put as much oxygen into it as you can to get as high an explosion as you can, as high as the temperature as you can. You get very, very high temperatures to get the explosion against your heads. In this particular case, those temperatures won't be over 200 to 250 degrees Fahrenheit. Your car engine is running at very high temperatures, and what is that doing to the metal? That fatigues the metal. What is that doing to the pistons? It fatigues the pistons. What's it doing to the cylinders, to the bearings? You are wearing your engine out because of the high temperatures that you have. There will be no high temperatures with this engine at all. You can walk over there and put your hand on the engine while it's running. Now, so you'll have low temperatures. You'll have more of an even, steady push all the way through that cycle. Not just whenever you get back over here where you're ready for power, that's when you'll still have the push, the drive in that cylinder, and so you'll get more power out of it. But you also, at the same time, you've got rings in your engine now, and you're getting hydrocarbon burn on the top end. And what's happening is the hydrocarbons are slipping past the rings, and what does that do to your oil? It dirties your oil up. Well, we anticipate that when we rebuild your car, one rebuild will last you from 400 to 500,000 miles. One rebuild. 500,000 miles on one rebuild. Number one. Number two, since you don't have the hydrocarbons slipping past the rings, you will change the oil when you rebuild the car. You will not change the oil for the whole 500,000 miles. No more oil changes. Number three, you have to change the filter when you first do it because you might get iron filings back in there when we modify your car. So you have to change the oil filter, but you will not have to change the filter again for the whole time that you got the car. So no more oil changes, no more oil filter changes, and your car goes 500,000 miles, possibly more, on one rebuild. Same engine you got now. I got a whole questions because I got a lot of stuff to go through here, right? But I like to answer, believe me. Anyway, so now, but you have to drive your car on something. Ladies and gentlemen, there has to be a power source. Energy has to come from somewhere. So how are you going to drive this engine? Because, ladies and gentlemen, when we modify your car, we're going to go down there, we're going to take that gas tank off, and we're going to rip that beast out of there, and we're going to throw that thing away. Your car will never, ever again have a gas tank on it or an exhaust system on it. And so how are you going to power the car? You're going to have energy on board to be able to power the car. Well, now we'll get to this baby right here. This is the world's most efficient thermal storage device. It holds high temperatures in small spaces for long periods of time. Now, this is a little 4-pack. You see the cells there? You could have a 6-pack or whatever. But right here, you got the heat source. It is an electric cow rod. So an electric cow rod goes right down into that unit and can heat these units up. You plug it into electricity. Then you can store thermal energy. Well, thermal energy, ladies and gentlemen, in one of these cells, we developed and found, actually discovered, didn't develop, discovered a storage mass that has 9 times the specific heat of sand. 9 times the specific heat of sand. Now, we developed this with sand originally. We could get 35,000 BTUs in a cubic foot, and we had the world's record on thermal storage. We already had the world's record. We then found something 9 times as good. We can hold 9 times as much heat energy, and in one of those little 4-packs, this unit right here will hold about between 50 and 60,000 BTUs of heat energy, right here. 50 to 60,000 BTUs. In a 4-pack, we can hold about 250,000 BTUs of heat energy in here. 250,000 BTUs of heat energy. Now, how many of these could we put in the engine compartment? But we also, of course, could put them where the gas tank used to be. We can even build these little cells into the frame of the car itself. We can give you all the thermal storage that you need, because if your engine is running 50% efficient, guess how efficient the engine you got right now runs? Probably about 20%. So you're now running about 20%. So when we take that thermal storage mass with the additional efficiency of the engine, one of these little storage cells, a 4-pack here, could give you somewhere around the equivalent of a tank of gasoline. And so we can put several what would be the equivalent of tanks of gasoline on board, and then in order to get that heat energy, all you do is have to plug your electric cow rods in. So you have to remember to plug in your electricity and make electricity, use electricity to make that heat. Well, that wouldn't be too great. Of course, the stupidest idea I ever heard in my life was the electric car. This is the dumbest idea I have ever heard. The reason why I think this electric car is so stupid is because people are trying to claim that if we go buy the $50,000 electric car, we won't be polluting the environment anymore, because electric is a clean source of energy and we don't pollute the environment with it. Of course, the part that they forget to tell us is that the most polluting thing we can do is use the power plant to make the electricity in the first place. And so we're burning coal, building acid rain, destroying the environment, doing far more damage at the electric company than we could ever do at the car, and then we're using the electricity to power the car. What's wrong with this picture here? As a matter of fact, sometimes I think if this is the Department of Energy that we've got protecting us and looking out for our interests, I oftentimes wonder who we're going to get to protect us from the people we got protecting us. Now, I'm advocating the same thing. I'm advocating pulling up there and putting heat into this. Now, you can put heat into it a lot of different ways besides electricity, but the reason why is because we're going to give you a unit that you can put outside of your house that can harmlessly suck the energy out of the environment and produce all the electricity you need for free. So guess what? When it harmlessly takes the energy out and produces all the electricity at your house for free, it's also going to run your car for free. So your car is going to be run on the energy we suck out of the air absolutely free. Not only will you never stop at a gas station again, you'll never pay another dime to go another mile with your car when we put those two technologies together. And you'll never pollute the environment in any way. Now, you might be wondering, wait a minute here. He said he's going to put high temperatures in here. How is he going to insulate this? Because if I put really high temperatures, hot goes to cold. Remember the second law of thermodynamics? So if this is 2,000 degrees, have to use something besides copper if I'm going to get above that. But this is 2,000 degrees. How can I insulate this so that you wouldn't be losing all the heat as you're going down the road? Well, ladies and gentlemen, I can insulate this so I can pick it up with my hand and it's 2,000 degrees. I can insulate this so that I can do that. And for you to understand how we can do that, I'm going to show you the next piece of film. The next videotape that we have is on the insulation. We also, by the way, can use carbon fibers and wrap all of this in carbon fibers, because carbon fiber is one of the strongest substances known to man. This little piece of plastic is wound in carbon fibers, and you can stand on it all day. You can't break it. And the carbon fibers, by the way, that's how they make tennis rackets that you can't break. Carbon fibers will hold 250,000 pounds per square inch. When a spaceship leaves the Earth on a launching pad, it leaves with the thrust to overcome the Earth's gravity of 250,000 pounds per square inch. If you had a rope 1 square inch of this over the nose cone, it would never leave the launching pad. You see how strong that is? Very inexpensive. I can wrap that whole thing for about $50. So we then will wrap that so that if you're driving down the road and you hit something like a brick wall, you don't have these little bullets in your lap or anything. That'd be a little uncomfortable, 2,000 degrees. So we've got them wrapped so that they're collision proof also. But let me show you how we could insulate these. Next slide, next film. Go ahead, Tommy. Watch the TV monitor.
Discovery Starlight, or my plastic, and keeps it not in a safe or an armored car, but close by his side in a simple glass jar.
Like cake flour or plaster, that's right.
His plastic, Starlight, can be rigid or rubbery. It can even be paste. But whatever the form, when Morris applies his invention to another surface and then applies heat to that surface, well, watch what happens.
And you can see
A plastic that refuses to burn. A discovery that any Nobel Prize-winning scientist would envy.
the world has spent billions of pounds for the last 45 years with thousands of the top physicists and Doctor Who's without any success. I've come in, I believe, from a different angle.
Under a butane torch at approximately 2,200 degrees Fahrenheit, the plastic glows red, even bubbles a bit, but it refuses to ignite.
I move the torch away, like so.
You can barely feel it.
Well, just watch this. If I turn the flame off and remember that it was producing 1,200 degrees Celsius, if I then crack it open, what's more, the egg hasn't even begun to start cooking.
All right, now, so if you're wondering how we could insulate that, that can give you some ideas. Now, the next thing we're going to show you is a thing that comes from a gentleman named Professor Yul Brown. You can go ahead and you get started over here and turn it on. Professor Yul Brown is a friend of mine. Professor Yul Brown is a genius. Professor Yul Brown is a man who developed a process for taking regular, ordinary tap water, and you can separate the hydrogen from the oxygen in the tap water. Well, we've known how to separate hydrogen from oxygen for a long period of time. However, when you separate it, Yul Brown knows something no other man in the world knows. You know what he knows? What happens, anybody here that's technical, what happens when you take hydrogen and oxygen and you mix them together? You get an explosion. Exactly right, it explodes. It blows up. You cannot put hydrogen with oxygen and mix them together. They'll blow up. And Professor Yul Brown has separated the hydrogen from the oxygen and mixes them together in a stoichiometric mixture, and he does not get an explosion at all. What he gets is Brown's gas. So here, ladies and gentlemen, we're going to show you a whole new substance called Brown's gas. Now, Brown's gas is made with 1 liter of water. You can make 2,000 liters, 1860, of Brown's gas. So he converts water into Brown's gas at a 1,860 to 1 ratio. And when he makes this hydrogen oxygen, he makes HHO. And HHO is a whole new substance. We said with water we can have ice, we can have liquid, or we can have steam. Steam is supposed to be the gaseous state of water. Well, now there's a new one, Brown's gas, which is a gas. Now, if you supply a fire or a spark to Brown's gas, it will not explode. So you got Brown's gas, hydrogen, oxygen, right mixture. It will not explode, it will implode. So when you do that, it will implode, and it is the only substance in the world that will implode. So this new substance created by this brilliant man, not found anywhere in nature at all, and this new substance, when you put sparks into it, will implode. You know, the opposite of explode is implode. And as it implodes, you can now weld with it. Now, you can utilize this by, you just pour water in the back end of this machine and you start welding. There is no oxyacetylene at all. What my friend is going to do is apply this to a brick. Normally with an oxyacetylene welding unit, you would then blow the brick up. How many people here have welded before? Anybody? Well, good. Man, lots of people have welded. Well, get ready, because your world is about to get rocked, because right here he's going to put a hole in the brick, but actually when he puts a hole in the brick, he's going to take a piece of steel, and he's going to take a piece of steel rod and weld it to the brick. You know, this is just your ordinary old brick to steel rod welding trick here. And by the way, do you know that you can't weld to similar metals? You can't weld copper to brass, to steel, to aluminum. Well, guess what? With this equipment, you can weld any two dissimilar metals together. You can put steel to aluminum, steel to brass, brass to copper, anything you want, because this flame right here, whenever he is utilizing this flame, it is the same flame every time it is applied to any other material, but whatever material it is applied to will determine the temperature that is going on. In other words, you can use this flame to take 2 pieces of aluminum, put a beautiful little weld on them, even if you've never welded aluminum before in your life. You don't need to get certified to weld aluminum. If you can braze, you can weld aluminum with this. You can now put 2 pieces of aluminum together at 900 degrees Fahrenheit. With the same flame, with the same unit, you then can put 2 pieces of copper together at 1800 degrees Fahrenheit. With the same flame, same unit, you can apply it to the brick there at 3000 degrees Fahrenheit. And ladies and gentlemen, whatever material this comes in contact with will determine the temperature of that weld. So it's the material itself that determines what temperature that welding process is happening at. We can take a piece of tungsten. How many people here know what tungsten is? That's what's in your light bulb. The reason why they have it is because it's one of the most heat-resistant materials that you can get for that resistor. We can take a piece of tungsten and we can sublimate tungsten. Do you know what temperature it takes to sublimate tungsten? It takes 5,950 degrees Celsius. That is over 13,000 degrees Fahrenheit. However, we can sublimate a piece of tungsten with this same flame right here. Same flame. We can sublimate a piece of tungsten at temperatures close to the temperature of the sun. As a matter of fact, we have a piece of tungsten here, don't we? This is a piece of tungsten. Comes from a tungsten container there. Okay, we have a piece of tungsten. We invite anybody to call ahead, and you know what our tour schedule is. Have somebody show up with a piece of tungsten so we can take your tungsten and do this. We've had 2 people do that on our trip so far. One guy came up with 2 great big chunks of tungsten, and instead of sublimating them, we welded the 2 of them together with that same flame. We welded them together, and they sublimated in the process. Sublimating, by the way, turns it into smoke. It doesn't melt, it just turns into white smoke. So if we put this right here, I'll put it on the aluminum, okay. All right, Mike's going to hold it on the aluminum. And now what we will do is he's just going to concentrate that flame right into tungsten. Now that is a piece of tungsten. You see how bright it's going to get. Don't look directly into it. It's going to get real, real, real bright. The same thing that, and you're going to see it start sublimating here, giving off a big white smoke. You see the smoke? You see the smoke, ladies and gentlemen? It's being done over the top of a piece of aluminum, and the aluminum is not even melting. It's a concentrate. You see that? We are sublimating tungsten. That's 6,000 Celsius. That's about 13,000 degrees Fahrenheit. And we're sublimating tungsten. The same flame, of course, I can put my hand through. And also, I want to just now hold it. Yeah. There's the piece of steel that we welded to a brick. By the way, we can continue to put the flame on the brick and turn the brick into glass. Yeah. When we turn the brick into glass, you can just pick that up, Mike, if you want. When we turn the brick into glass, the glass itself is so hard, the hardness of diamond is a 10. The hardness of the glass of that brick will be 9.5. Okay? Now, this unit, we also can weld glass to brick. So just, well, you know, your ordinary old weld glass to brick trick here. We can weld, this is copper, steel to copper, brass to steel, aluminum to brass. Any 2 metals can be welded together. Any 2 metals. Now, also if we took this flame and we took a piece of meat and put it up here, that piece of meat would be disintegrated. There'd be no ash whatsoever. What could that do for medical waste? Now I need one volunteer from the audience here. You notice I said it right after I said that piece of meat would be disintegrated? Oh, come on, one finger. I mean, come on, one, you know, it's finger to one. All right, come on. Okay, one finger, maybe an ear tip. All right, no problem. Come on up here. He can weld it back together again, no problem. Now, wait, before you do it, what we're going to do is we're going to take a piece of aluminum here. Now remember, we put water in here to get started, so we're not welding with oxyacetylene. There's no more oxyacetylene. We can MIG, TIG, we can also weld, we can cut. No oxyacetylene at all. But we're going to show you what the exhaust is when we weld. And so go ahead and hit this piece of aluminum, and our man from the audience, what's your name?
Jim.
Jim is going to tell us, what is the exhaust there? What's it exhausting?
It looks like water.
Yeah. Put your hand on it, it's water. So it's exhausting water. It's not real hot, is it? Warm. Just warm. Okay, thank you. So the exhaust when we weld with this unit is water. So we're taking water, turning it into Brown's gas, welding with it all the way up to the temperature of the sun, whatever material you want to use. Any two materials can go together. Can you put silver with gold? Yes, you can. Any material at all you can put together. You can take plastic and weld it to metal. And you can also do all kinds of other wonderful things with it. But one thing I'm going to show you here, I'm going to take this ordinary brick and I'm going to stick it in water. Now, I'm just going to leave it there in the water, and you guys are all going to remind me that we got that brick sitting in the water. We're going to come back to this in a minute. We're going to show you another thing marvelous about the Brown's gas machine. And by the way, Brown's gas can be used to completely eliminate toxic waste. Take toxic waste, apply Brown's gas to it, and you can completely disseminate all the toxic waste with no noxious oxides hitting the environment at all with Brown's gas. Now, what these guys are going to do is we're going to take the water from this cylinder up here. We're going to release the water into the cylinder down. Once the cylinder is completely full of Brown's gas at an 1860-to-1 ratio, because 1 liter of water makes 1,860 liters of Brown's gas, then we're going to hit this cylinder, once it's full of gas, with a spark on this spark plug. When we spark the gas inside the cylinder, we're not going to get an explosion, we're going to get an implosion. Now when it implodes, it's going to turn from 2,000 or 1,860 particles of Brown's gas into 1 particle of water. So we're going to have a couple of drops of water inside the cylinder as it implodes. Now when it implodes, what else is it going to cause? What happens when you got 2,000 particles that become 1 particle? You're going to have a vacuum. Yes. So now we're going to draw an instantaneous vacuum. I don't know if you've ever waited to draw a vacuum before, but an instantaneous vacuum is pretty phenomenal. And so when we make an instantaneous vacuum inside of here, after we get the Brown's gas totally in there, we're going to implode it. When we do, the spark will happen. You'll hear it like a little pop, be kind of like a firecracker. And that's not because anything is blowing up at all. The reason why you're going to hear the pop is because the cylinders out here, the air out here, don't do it yet, the air out here that we have, that we're sitting in, has 14.7 psi. So it's on our body now, 14 pounds of pressure on us from the air. That's the air pressure. And so right now the air pressure is going to be pushing against this cylinder. When we draw the vacuum, what's going to happen? The air pressure is going to try to collapse that cylinder. That's what the pop is. It's going to try to collapse it like a Coke can. And it won't be able to, but that's going to be the noise. Now, then when we got the vacuum inside of here, this is a vacuum gauge. On this side, there's no vacuum. We've got a little stopcock here that's closed. But then after we get the pop and we create the vacuum, then we're going to open this little stopcock and we're going to show you there is a vacuum inside of here. We can't do it before, we'll break the gauge. An instantaneous vacuum isn't good on a vacuum gauge. And then you'll see the vacuum go over here. This needle will go all the way to this side over here, showing you that there is a vacuum inside of here. And then we're going to show you something really marvelous. We're going to show you the implosion engine cycle. A whole nother engine cycle. Now, we ready to do it? Okay, go ahead and give us a pop. Okay, you heard that little bang? Okay, that was this thing trying to collapse. And now we're going to show you that we do have a vacuum. Go ahead. See, we got a vacuum. So there's the vacuum on the vacuum side of the gauge. Now, if there's a vacuum in here, and we got a piston in here, on this side of the piston, we've got 5 50-pound weights. What is 5 times 50 pounds? 250 pounds. Now, if we were going to then, don't know yet, if we open this valve right here, the air that we're sitting in, the air right here, would start rushing in to fill that vacuum, wouldn't it? And as the air rushes in to fill the vacuum, it's going to lift the piston with 250 pounds on it, 1 foot in the air. Isn't that 250 foot-pounds? 250 pounds a foot in the air? And so, can you imagine using the air that we're sitting in to exert 250 foot-pounds of torque? Well, you're going to see it right before your very eyes. And of course, what is the hold a second. What is the exhaust going to be? Water. So the exhaust will be water. So it's an engine cycle, the exhaust is water. Now do it slowly so we can lift it up slowly. Okay? Go ahead. Just keep on coming. All right, there it is, ladies and gentlemen. Lifting 250 pounds, 1 foot in the air. Yes, sir. We are using the air that we are sitting in to give us 250 foot-pounds of torque. And now what is the other side of this cycle on the implosion engine? Are we saying that someday your car could actually be run on nothing but the air itself by just merely imploding water or Brown's gas and the exhaust would be water? Yeah, pretty much what we're saying. All right, now the other side of the cycle is going to be gravity. Go ahead. And how do we return the piston? We return it with gravity. We let gravity do the job. So the air pulls it up, gravity pushes it down, air pulls it up, gravity pushes it down. And so now we have just shown you a second engine cycle that runs with no negatively environmental impact at all. Now everybody repeat after me. It's impossible. It's impossible. It's impossible. Nothing implodes. An implosion is impossible. An implosion engine is impossible. Taking water and welding all the similar metals together, that's impossible. Being able to melt, to put steel with brick, impossible. Glass with brick, impossible. Ladies and gentlemen, all of this is impossible. Run an engine with no gasoline at all. That's impossible. An engine that runs in a closed loop with no condenser. Ladies and gentlemen, that is impossible. Taking solar energy out of a snow blizzard in the middle of the night. Impossible. Utilizing that to make electricity that you can melt steel with. Impossible. Good. We're starting to see that there's a different definition for the word impossible than the one that everybody's been using. If you go to a physicist and you say, can we do this? He's going to tell you, no. That's impossible. Okay? And the reason why is because he doesn't know how to do it. And the reason why he doesn't know how to do it is because he didn't come. Now, over here, we're going to show you yet another engine cycle. Free electricity, again, not one way, not two way, not three ways, but 4 ways to make free electricity. Right here is an engine we call the Stirling engine. This is the Stirling engine cycle. Now, over here he is putting heat on the front end of this cycle. So he's got a little nose over here, and he's got heat on the nose of it. As the heat is on the nose, the engine is running. Maybe you can hear it and see it. As long as heat is on the front end of this nose, that engine will run. Because heat is on one side and it's cool on this side, and so the high pressure is going to the low pressure, building up the pressure to return it, and it just sit there and cycle. As long as you got heat on the nose cone, that will sit there and run. It'll run all day, run all night, run forever. Now, so any way you can find heat to put on the nose cone of that would be the way that you could make electricity or mechanical energy or power. How could you supply heat to do that? Well, how about this? We have another product that is a smokeless stove. A smokeless stove, ladies and gentlemen. You can burn anything in it. Boots, shoes, chicken bones, all the stuff that you call garbage at your house, you can burn it. You can burn pig poop in this burner. You can burn corn stalks. If you're a dairy farmer, you could even take the cow chips, throw them inside of there, and get the heat, apply the heat to the nose cone of this little Stirling engine, and be producing electricity that's running the milkers that's milking the cows. And you could use all the water for cleanup. Let me show you the smokeless stove that you could take that unit, stick the nose of it right into the fire of this stove, and you could burn anything that you have, no smoke whatsoever. It burns 4,000 degrees Fahrenheit, and it will burn anything, no smoke whatsoever, and then you can also be able to make all of your electricity at your home for free. Next video. Let's do the video, Tommy.
Together it looks like this. Inside the stove we have our hot fire burning. You can tell by the flames that this is generally a little bit hotter fire than you're used to seeing in your stove. That, of course, is because of the forced draft. The next thing we want to look at is the temperature that's inside the storage tank. We've got a hot fire and the water in the tank is just about 160 degrees. So our gases are going through 160-degree water. However, by the time they get to the chimney, they're under 200 degrees. 200 is straight up and down on the gauge. And we look at the top of the chimney, and except for a piece of ash now and then, there's no smoke coming out at all. The little pieces of ash are because we've got about a 5.5-foot chimney on it. Most people wouldn't use one that small.
Okay, now, so far isn't it interesting that the Department of Energy has not told you about any of this stuff at all? The media has not told you about any of this stuff at all. And you guys are sitting here waiting for all these guys to protect you. Anyway, over here we've got another process where you can make free electricity. Now, here's one they've told you about. The windmill. Guys, you can use the windmill to make your electricity. Of course, the fact is, maybe you don't have any wind. Oh, well, you can't use it, but somebody can. Well, here's the one that they're promoting. It's called the Whisper. The Whisper is a great big blade. And by the way, in a 3-mile-an-hour wind, it just sits there. It whispers so much it doesn't move at all. Now, that's a real whisper. Here we have a shop van. This one right here is the most efficient solar wind machine in the world today. It runs with a Venturi concept. In a 3-mile-an-hour wind, it will produce 6 kW of electricity in a 3-mile-an-hour wind. You got a 10-mile-an-hour wind, it's better. Now your whisper will start turning on too. So this one here is the world's most efficient. Go ahead and shut it down. And you notice that while we're doing that one, we're also doing this one right here. This is a very high torque, low RPM blade. High torque, low RPM. It works just like your car. 1, 4, 3, 2. See that? And so in essence, if you put it like this, guess what it is? It's a water wheel. So you got the wind, but this is the most efficient water wheel in the world today. Now, how can you make electricity with water? How can you make electricity with water on a water wheel? Well, if you got a waterfall and it falls 10 feet, you can do that, right? Falls 20 feet, you can do that. Falls 5 feet, you can do that, right? Falls 2 feet, you can do that, right? You can. And what if there's no waterfall at all? You just got a creek running through your property. Ladies and gentlemen, you can make electricity. So this is the most efficient in the world. Of course, you haven't heard about them, but you have heard about some of them. And so we'll just keep moving along. But what you can do with this one right here is very, very, very incredible. It's a very high torque, low RPM unit. But this right here is a torque intensifier. You know, your ordinary, everyday torque intensifier. You guys have heard of torque intensifiers, haven't you? That's where you take torque, the power, torque is pull. Like here we use torque. We picked up that 250 pounds a foot. That was 250 foot-pounds of torque. So it's the pulling power. Well, if I put RPMs, like 1,000 RPMs against the wheel at the bottom, the top one will turn at 1,000 RPMs. Whatever RPMs I put at the bottom, the top one will turn at. But you see the geometry of what's going on right there? Well, actually, we can magnify the torque 2 to 1. So if I put 100 foot-pounds of torque in the bottom at 1,000 RPM, I'll get 200 foot-pounds of torque out of the top at 1,000 RPM. Oh, come on. That's impossible. Okay, anyway, let's see the videotape here of the torque amplifier and let you meet Mr. Murray. This is the world's leading expert on Nikola Tesla.
Today we're going to demonstrate for you a technology which has been kept under wraps for about 20 years. The device that I'm standing next to is referred to as a GravTAC, gravitational torque amplifier. And as the name insinuates, the device is capable of extracting useful work from the Earth's gravitational field. Now, according to the traditional wisdom, this is not something which is possible. As you probably know, there are 3 basic static fields known to man. There's your electrostatic field, your magnetic field, and the gravitational field. Back in the 1800s, Nikola Tesla proved that useful work could be extracted from the Earth's electrostatic field. Following similar lines of thought expressed by Tesla, we've been able to demonstrate that there is useful work that can be extracted from the Earth's gravitational field. Now, I can't dwell too long or in too much depth on the principles behind this machine because they are proprietary. And I will also caution you that some parts of the machine which are essential for its operation are not going to be demonstrated here with this model. However, without further ado, let me start the machine so that you can watch it function and you can contemplate its unusual geometry.
That's the gravitational fields of the Earth. That we're utilizing.
Now, the power input to this device is here at the bottom to the small electric motor, and the power output, which is shown here at the top, is delivering torque into a pony brake. Now, it's true that this is not instrumented at this time, however it can be, and naturally the purpose for that would be to measure the output torque. It's interesting to notice that the machine input and output speeds are equal. And that's about all I'm going to say concerning the functionality of the device. So you can watch the thing function for a while and contemplate the meaning of the geometry, and I'm sure that Mr. Lee will touch upon it further if he chooses to do so. Thank you for your attention.
By the way, that unit will be demonstrated at Philadelphia, at the Philadelphia show, live, and we will be testing the torque on the unit. So if you want to come and see it, you can certainly do that. Welcome to come to Philadelphia. The Philadelphia show is going to be the ending show that is the beginning of something we're doing. By the way, in case you guys are wondering, I've kind of been putting down the Department of Energy a lot. And the main reason why I've been putting down the Department of Energy is because they deserve it. I don't know how many of you people have ever been asked if you wanted to have a Department of Energy. Has anyone ever voted for the Department of Energy? No. Has anyone ever voted that O'Leary could be the head of the Department of Energy? and then she could fly around with a whole entourage of people all across the world. You know why she needs 30 or 40 people to go with her is because that's how many it takes to tell her how wonderful she is. It's like if you give me a free trip, maybe I'll tell you how wonderful you were too. Anyhow, ladies and gentlemen, the Department of Energy has not told you any of this or anything about the rest of the things we're going to show you. And the main reason why they haven't done that is because the Department of Energy is the Department of Energy for corporate America. So corporate America has a Department of Energy. We felt like it would only be fitting in America that the people had a Department of Energy as well. I mean, if the corporations have one, why can't the people have one? And so, ladies and gentlemen, we've decided to take on that job. Better World Technology is announcing all across America as we go across this country that we are going to become the People's Department of Energy. The corporate America has one. They spend billions of taxpayers' dollars. They develop nothing. They do indeed keep everybody away from all the technologies that we have. And so we used about $2 million, and we're bringing you all the technologies that we've got here, and far, far more technologies. We're going to be showing you some more. But the technologies that we're developing we're just developing to take them out to the market because, you see, here's where we're going to do. We believe the free enterprise system works. It's kind of weird. It's an unpopular way to believe in America, but we don't believe that we need to have somebody socialistically tell us everything that we need to do. We don't believe we need centralized government to be Big Brother to turn around and tell us whether we can go out and do anything or not. We believe that the profit motive alone will be good enough to bring technologies out. And so we have pledged ourselves to become your Department of Energy, but not just your Department of Energy. We're going to bring the technologies to you. We're not just going to tell you about them. We're going to put them on your homes, put them in your cars, put them into action across the country, and then let the corporate Department of Energy do whatever it is they do best. I don't know what in the world they're doing. Okay? But we are going to become your Department of Energy, and that's part of what's happening at Philadelphia on the 23rd of September. We are going to take over as the Department of Energy for the people of this country. And we're not asking anybody's permission. Thank you. As long as one of you want us to be your Department of Energy, we will be your Department of Energy. Now, we'll let you know what's really going on. We'll show you all the technologies, but we're also going to take them and put them on your houses. Now, by the way, there's another form of pollution, and he said there's only 3 kinds of static energy, but there's a 4th kind. It's called government. Yeah, there's another form of pollution that you hate. You people hate this. Now, you know how long we've had all of this? For about 20 years. All these technologies have been over a decade. All the things you've seen today have been bouncing around for over a decade, and you never knew about them. Isn't that amazing? Now, let me tell you something else. There's a form of pollution that you hate. You hate it. Everybody here hates it. And you know what? It bothers every single one of us. Has anyone here ever run a jackhammer? Did you ever run a jackhammer? How about the noise pollution? Do we like that? Has that ever bothered you at all, the noise pollution, when somebody's out there beating up something with a jackhammer? And by the way, if you've ever run a jackhammer, does it make any noise at all? And for those of you who raised your hand and said you run a jackhammer, do you have any teeth left? You know what I'm talking about? The vibration of that thing will kill you. Well, it's going to shock you a little bit to know that we have found a noiseless jackhammer that also has no vibration at all. Now here it is right here. Is it making any noise at all? Doesn't make any noise, does it? It's not plugged in, I'm sorry. I'm going to take you to a videotape, and we're going to show you a jackhammer in comparison to the ones out there now. It makes very little noise, and it has no vibration at all. And we're going to show you a technology that has been here for 15 years. Ladies and gentlemen, for 15 years, we could have eliminated that noise problem. And can somebody here tell me why we haven't eliminated it? why we haven't moved to these types of welders, why we haven't moved to free electricity, why we burn gasoline in our cars? Of course you can. Anyway, go ahead and turn the video on, and I'm going to show you a noiseless jackhammer. See, no noise at all.
It's the old jackhammer versus the new jackhammer. This is what Hardale Industries of Springfield hopes will be the jackhammer or breaker of the future. It's taken developers nearly 5 decades, hundreds of thousands of dollars, and a lot of work, but Hardale thinks it's come up with the most effective and only vibrationless jackhammer in the world.
And as a result of vibration elimination, you reduce the harmful effects to the operator, number one. You reduce the harmful effects to the tool itself, number two. Number three, you get a more efficient usage of the impact energy. It's all directed to the tool that does the braking, which means that it is a more efficient tool and can run on less horsepower.
Developers say the whole secret to the breaker's success is its efficient use of air. Instead of the operator absorbing the vibration, air is forced into the breaker and onto the concrete. Hardale says it can cut a surface faster than existing hammers. To prove just how still this new tool is, Hardale's operator put this quarter on top of the machine. It didn't fall off. And you don't have to be very big to handle it. About 30 pounds of pressure will do.
Okay, now, so that would revolutionize jackhammers, right? But why don't we have those jackhammers? Because the people who sell jackhammers don't want to revolutionize the jackhammer industry, right? You guys know how this works. And it's like the guys that are in the welding equipment that sell the oxyacetylene, would they feel really happy about being able to just pour some tap water into the back end of a welder and be able to do anything to weld any materials together? Probably not. And so it's like, if the welding guys are already there and they're already selling the other welding equipment, why would they want to do that? If the jackhammer guys are already there and powerful and they've got lobbies and they've got politicians in their hip pocket, why would they want to convert that? And so the same thing is happening with the gas and the oil and the electric. And is there anybody here that doesn't know this? No. Everybody knows this. We all know what the problem is, don't we? Okay, anyway. Oh, I was going to have you remind me to take the brick out of the water. Mike has been doing it while I'm talking. I'm sorry, I normally pull it out. And Mike is going to now take a little electrode and hook it up to it, because that brick is a battery brick. You know, your ordinary run-of-the-mill battery brick, you can hold 1 volt of electricity in 1 brick. And so if you build a brick house, you could have a lot of volts of electricity, couldn't you? Anyway, it'll start climbing in its voltage as it's going. But while we're doing that, we're going to run the next clip for you, the next videotape. And there is a new paint out, ladies and gentlemen. This is a new paint. This paint, you can paint anything. You hook up to 2 little electrodes with it with low voltage, and it will transfer heat through the paint. I'm going to let the film tell you all about this new heat paint, and then you can use your imagination if you got a battery brick, what you can do. This guy's just painting this thing up here, and he's going to do something with it. Hook up his little low voltage electricity to it. Oh yes, some butter. And cook himself an egg.
It uses 35% less energy than conventional heat generating systems. 800 degrees Celsius can be achieved with only 100 volts. The company says that it's identified more than 200 applications. The paint can either be brushed on or sprayed on to almost any surface you could think of, and even to a few that you might not think of. Like this sample material to be used as lining to warm up the fashion conscious. Battery-powered lining in clothes may soon be on the catwalks and in the shops, but it's the industrial applications of the paint which will have the most impact. Because of its viscosity, shape is no barrier, and that opens a range of possibilities. It could mean new methods of de-icing aeroplane wings, tarmacs, railways and roads. But direct application isn't always viable, and MRX offers alternatives. Imagine this such a tiled bathroom floor with water-filled, heat-conducting pipes underneath. Now, normally the water is heated by conventional means, but with this new system, we have a boiler here that's insulated and also coated with the MRX paint. The boiler is connected by wire to a low voltage system, which heats the paint, which heats the water. Power consumption for underfloor and radiating heaters can be as high as 280 watts per square metre. But with MRX applied under the floors, to the walls and ceiling linings, Rustell claims that consumption per square metre could be reduced to just 76 watts. That would make the cost up to 75% cheaper. And unlike traditional radiators, which concentrate heat in only one area, the paint spreads the heat evenly over the treated surfaces. And it's not only under and in the house, it's soon to be applied to the top of the house as well, to be put on roofs to melt snow. In fact, paint panels like these will not only be producing heat from electricity, they'll be generating their own energy by harnessing the rays of the sun.
Okay, now, why isn't your Department of Energy telling you about these things? If you could take Brown's gas, you could take a brick, you could make a battery brick, you could get voltage, you could run the voltage into a paint, you could be heating your whole house with the energy, or refrigerating your whole house with the energy that you're getting from the environment itself. You don't even need a mechanical device. Why aren't they telling us about this? Well, you know what? Your Department of Energy is telling you about this, because we're your Department of Energy. We are going to take on the job of being your Department of Energy. Why are we going to do this? Because we're going to take out technologies and we're going to believe. We are going to believe that we have a great country. We are going to believe that America is the land of the free and is the home of the brave. We are going to believe that you deserve to have the best. We are going to believe this enough that we're going to do it. We're going to practice it, folks. We're not going to talk about what's wrong. We're going to do what is right. That's what we're going to do. We're not going to ask anyone's permission because we don't want any funding. We don't need any funding. We're not going to get the government to give us a grant because we know what happens with the grants. Your hands get tied, your feet get tied, and you're a man that is corn-fed until you're slaughtered. Well, quite frankly, ladies and gentlemen, we'd rather move around a little bit. And so we are taking this responsibility on ourselves because guess what? We are Americans. We believe in free enterprise. We believe that by taking the quality merchandise to the consumer will do what they're supposed to do, and then our country will be healed. We won't be sick anymore. And so we're believing in that, and that's what we're going to do. Now, in case you haven't realized how sick your country is, and by the way, all of these things are here, we're not showing you 2% of the answers that we have, because it would take all week long for us to show you all the technologies. All we can show you is a few dozen of them. We're not done yet. We've got some more. But ladies and gentlemen, the next one that I'm going to show you should make you sick. This should get you upset. And you know why? Because it isn't anything that is to your advantage. It's a betrayal. And a betrayal should make you sick. When I learned about this one here, I didn't want to know this. You know it's bad. You know it's really bad. You know they're ignoring it. But whenever you find that they're just deliberately screwing the general public, it really antagonizes you a little bit more than just if they're kind of like maybe too busy to look into something. Well, ladies and gentlemen, the next one right over here I'm going to talk about is electric motors. Now, how many people here have anything that's run on an electric motor? Oh, I'm sorry, I did that wrong. how many people here do not have anything that's run on an electric motor? There probably are some people here, and they're probably right, by the way. Anyway, electric motors, if we went out to buy an electric motor, would we expect to get the best quality that we could for our money? Wouldn't we kind of expect that? You'd think, hey, a guy's going to build something, they're going to build the best. And so you go to the best. I mean, you go to GE, you go to all these big companies, corporate America, and you expect, by golly, to be treated like a king, because after all, you're the consumer. Well, ladies and gentlemen, let me tell you how the free enterprise system, the sick free enterprise system, works in America. The consumer doesn't matter. You people don't even measure in the equation. You guys are stupid. You'll buy whatever we sell you. That's the attitude. The attitude is, hey, if we're going to design a product, we really don't care what the consumer thinks about it, because we'll just run enough TV commercials, they'll buy the dumb thing. But we care about what the competitor says about it. You ever notice that? We're worried about the competitor. I'll give you an example of that right here. All you guys have thought of it. I'm going to give you an example. We're going to voice something that's in the back of your mind that you haven't let out yet. What do you think, speaking of competitor, what do you think the oil companies are going to do to me? What do you think the electric companies are going to do to me? Yeah. If I went around this room and I polled everybody in this room and I said, here's the question, what do you think the oil companies and the electric companies are going to do to me? You guys would all get it, right? You'd say, they're going to kill you. They're going to at least stop you. Well, let me tell you something, ladies and gentlemen. I find that to be so interesting. Here we are living in a society, and every single one of us know what's wrong, and we're in control. We're always told that we're the boss, yet every one of us knows what's wrong. Why does it continue? I wonder why it continues when we're the boss and we all know what's wrong. Anyway, that's an example of the competition. You see, you design a product, you say, what will the oil company say? And then you do it or don't do it based upon the kind of power that they will exert on you. Well, ladies and gentlemen, I'm an American. I am an American. I am a free man. I'm also a Christian. I'm a free man. God has set me free, and who has set me free has made me free indeed. I'm a free man. And if I'm going to be a free man, I've got to act like a free man. A free man doesn't worry about what his competition is going to do to him. A free man worries under God in delivering the best quality service and merchandise he can for the consumer. And it is time, ladies and gentlemen, that we got these people to start doing this right. It is time, ladies and gentlemen, for us to exercise a little bit of self-control. It is time, ladies and gentlemen, for us to exercise a little bit of courage. It is time, ladies and gentlemen, for us to exercise a little bit of faith in our God and in our country persons. It is time, ladies and gentlemen, for somebody to stop this stuff. I'll give you an example of what the problem is. Here's a little electric motor. Now, this electric motor is an electric motor you can go out and pick up. And by the way, this isn't an exception. Put any electric motor up here and I'll show you the same phenomenon. And when you take this electric motor, if you turn it on, it'll deliver the power. It'll run your refrigerator, it'll run your electric, it'll run what you need. But the problem is, it's out of tune. It's out of tune. Now, let's say that I sold you a radio and the radio never hit the station. It was always just a little out of tune. So you start to play the radio and it's always got that squelch in the background. Would you bring it back? Because, see, it's obvious to you it's out of tune. But how do you know when your electric motor's out of tune? Well, they're stupid. They don't know when an electric motor's out of tune. They'll buy the dumb electric motor, they'll put it in, it'll run the refrigerator, whatever. They don't know, they're stupid. Well, ladies and gentlemen, I just thought maybe I ought to show you so that then you would know. Rather than me taking advantage of your ignorance, I'm your Department of Energy. That's what Better World Technology is. We've accepted the responsibility. We're now going to start telling you the truth because we believe the truth will set you free. Right over here, with this electric motor, if I push this button down, the electric motor is going to, let's do it so you guys can film it there. The electric motor is going to give you some power, and it's going to supply power in here to this blower. Now we're not going to load the blower, we're just going to turn it on and see the kind of power that we got here. We got 120 because we're working on 120 volt electricity in here. So that's the voltage. The amperage says about 6 amps. Okay, you see this? We've got about 6 amps of electricity. And over here the watts is about 350 watts. So we got 350 watts of power being used, 6 amps at 120 volts. Now, I'm going to turn it off. Now that's the motor, the way it was wound and the way the circuitry is in that motor. Now what we're going to do is we're going to run it through a whole new circuit. We took the liberty of putting a different circuit next to that motor, one that's in tune. Our circuit is in tune. That's the circuit that we just saw that's out of tune by doing nothing more than tuning the circuit, like getting your channel on, tuning your radio. Have you ever tuned your radio? That's what we did here. We're going to tune this now, and by tuning this, we're going to route this electricity through our circuit to the same motor, and watch what happens. Oh my goodness, look at the amperage here. It's down to 2. Which is bigger, 6 or 2? And instead of using 350 watts of electricity, we're only using 250 watts of electricity. We're still running the same blower, the same motor, but we're using about 30% less electricity when we do it right. Now, isn't this an interesting thing? What an interesting phenomenon. Now, who do you think would benefit by that electric motor using more electricity? The electric supplier. Huh. And then, of course, the guys that wind all the electric motors and stuff, they get promoted by the electric companies so that we can buy the electric motors and stuff. And so guess what this is, folks? It's a standard case of the old good old boy routine. You lie and I'll swear to it. That's what the good old boy routine is. Well, I don't know about you, but I'm an American. That makes me sick. I don't want that in my country. So we're going to have to just get rid of that. That makes me sick. Now, over here we got another thing that I want to show you. It's another device. And ladies and gentlemen, once upon a time there was a man named Nikola Tesla. Nikola Tesla isn't in the history books, not all of them. Some of them he is. Kind of an honorable mention. Little asterisk next to Thomas Edison, one of the biggest idiots that ever lived, name. And this man, Nikola Tesla, this real genius, this real hero, who had the technology that could have set all of us free before I was born, this man, Nikola Tesla, he's got a Tesla Society named after him, and there's some people that are supposedly going out to honor his name. They're the same people who put Yule Brown down and said that would explode instead of implode. The Tesla Society. I love Nikola Tesla. I would give up 1 year of my life to have a one-day conversation with him. He's in the grave now, but I'd give up a year of my life just to talk to him for a day. I love the man. I love what he stood for. I love what he cared about. I love his genuine nature in science, to bring a thing forward because it was science, not because it was marketable or I could make any more money, but because it was God's best. That was the kind of man Nikola Tesla was. The thought that anybody would ever build a Dennis Lee Society, I guarantee you, if you do to me what you did, what the Tesla Society has done to Nikola Tesla, grave robbers who have taken his name, I'll come back from the grave and I will haunt you, I guarantee it. I don't believe in ghosts. I'll have God let me be one just so I can make your life miserable. I just thought I'd give you my promotional advertisement for the Tesla Society so everybody knew how much I endorse them. Let me tell you, all the people who say they're with the good guys ain't necessarily the good guys. All the people who say they're for the Patriot movement and for taking our country and getting our Constitution back again ain't necessarily about that at all. Matter of fact, the best way to control the competition is to be the competition, if you know what I'm talking about. Anyway, Nikola Tesla, he has a whole line of technologies. Do you know that Nikola Tesla invented the Fisher heat engine? He did, long before Victor Fisher ever did. Different variation of it. I hired a man who spent 30 years of his life studying Nikola Tesla, a man who loves Tesla, who is working with us now on some of Tesla's technologies. We, by the way, are going to bring the technologies out. We're not going to have a little unit up there that sends sparks through the air and makes everybody go, oh my God, a Tesla coil, look at all the sparks flying, which is nothing but a little baby thing. We're actually going to take some of the technologies Nikola Tesla intended for our society, and we're going to bring them out into our society. And we're going to do that even if the big boys don't like it. We don't care if the oil companies like what we're doing or not. They never asked me when they started polluting the planet to death, so why should I ask them when I start cleaning it up? And over here is a unit that Nikola Tesla developed. Now, we've gone forward and we've moved with this, but this is just a little bitty appetizer. The stuff that we're bringing out in through Tesla in the next year is going to shock you. I mean, we are going to revolutionize the world of energy in electric generators and electric usage. We're going to shock you. That's funny, with electricity. Now, when you thought of that. Okay, over here is a unit. That down there is a transforming generator. Now I'm going to talk about it, and I'm going to let David turn it on. The transforming generator here is an electromagnetic rotating device. Now, it is going to, we're going to show a sine wave. When we light this little light bulb over here, we're going to take electricity and light this light bulb. It's a flood lamp. We're going to first light it up because if this had ballast, this floodlight wouldn't light. So we're going to prove to you, using the floodlight, that we have no ballast at all in this unit. No ballast. Then after we light it up, we're going to take this floodlight out. We're going to put in a mercury vapor lamp. Now, a mercury vapor lamp will not light without ballast. And so when we screw that in, we're going to use the same unit, and we're going to light up the mercury vapor lamp with no ballast at all. No ballast. Now, then we're also going to show you that right here we'll get like a little sawtooth wave whenever we're doing the flood lamp. But if we wait here long enough with the mercury lamp, what we're going to do is we're going to get a square wave. Now, repeat after me. It is impossible to get a square or sine wave out of an electromagnetic rotating device. That is impossible, ladies and gentlemen. But we're going to do it anyway. We're giving some people who know something about electricity some clues about some things that we're going to be bringing forward with the Tesla inventions. But we also are going to show you something very practical, because when we light up the other bulb, we're going to get the same illumination using about 30% less wattage. So we get the same lumens for 30% less wattage. Thereby, we would be able to reduce the wattage in lighting up parking lots, football stadiums by 30%. And we also could do it selling them equipment with no ballast, and 40 to 50% of the equipment cost is the ballast. And so you can kind of wrap your brain around what that would do to that industry. Go ahead and turn it on. Okay, we'll go ahead and demonstrate this for you real quickly. By the way, there's all kinds of new technologies. The first thing we're going to do, light up this little bulb. Okay, so we got a flood lamp. We're lighting a regular flood lamp. Now, by the way, we have a dynamic flux mechanism in the major coil segments of that transforming generator. And it is going to change dependent upon the load. It is going to adjust itself to whatever the load is, and it will set up its own parametric source impedance, and it will adjust itself to the load regardless of the impedance on that motor. regardless of the impedance. Okay, now we're going to put in the mercury vapor light. Now this is impossible. This cannot light up now because there is no ballast here. Lighting that would now be impossible. It's impossible. Okay, now as we're running it, you saw the little sawtooth wave, the triangular wave, and now it's starting to adjust itself to a square wave. We got a different wave with that bulb than we had with the other one. And the machine is now adjusting itself to whatever the load is. So it will continue to adjust itself to the load as the bulb gets brighter and brighter and brighter. We will be approaching the square wave. Now all I'm going to do here today is just approach the square wave. If you get the videotape, you can see the square wave. Because for sake of argument, I just want to try to get a couple more things in before it gets too late. All right, so we'll go ahead and shut it down. But we are running the mercury vapor lamp with no ballast at all, and we're approaching the square wave. Okay? Okay, now, ladies and gentlemen, I've got some more things I want to show you and tell you about. But let me tell you about the most important one of this evening, or of the today. This is the most important one. I can solve all your energy problems, no problem. I can give you all your electricity for free, no problem. I can run all your automobiles with no gasoline whatsoever. I can even run your planes on water. And we're going to show you that in a minute. But ladies and gentlemen, there was one form of pollution, there was one major disaster in the energy field that I could not address. And it drove me crazy. You know what that one was? Nuclear. Nuclear power. The insanity of nuclear power will tell you just exactly who the Department of Energy is. These are people who have done everything in their power to promote nuclear power. They have been the big proponents of nuclear power and nuclear energy. Well, let me tell you something, how insane that was. When they went out to build the nuclear power plants, nobody knew how to decommission them. Nobody knew how to decommission a nuclear power plant. You're going to build a nuclear power plant, create lethal radioactivity, and you don't have any idea how you can stop it. Well, the idea was somebody will figure it out before it gets too far down the road. Nobody did. Governor Cuomo figured it out in New York. He said, here's how we decommission it. We shut the stupid thing down. That was the only way to decommission it, by the way. Chernobyl tried to decommission one with 30 pounds of cement over the top, 30 feet of cement over the top of it, and still didn't decommission it. And so now we create radioactive waste. Well, radioactive waste, ladies and gentlemen, is lethal. Plutonium rods. We use about 2% of this stuff for energy, 98% is waste. 1 pound of plutonium can wipe out every man, woman, and child on the planet. The average electric plant gets rid of 66,000 pounds a year. This is very interesting. We can take it, dig holes, and bury it. And it's lethal for 50,000 years. Of course, we can't find the pyramids 5,000 years later, but we can just stick this in holes in the ground. And ladies and gentlemen, there is no safe way to store radioactive nuclear waste. Doesn't exist. So that scared me. I'm like, hey, what are we going to do, God, with these idiots that we got out here looking out for us? These arrogant people who are so smart, so fancy pants, that they're intellectuals, and us dummies can't even talk to them or even get on the plane with them to communicate to them. How are we going to live past this arrogance, God? And I had no answer. Ladies and gentlemen, until I met Professor Yul Brown, I had no answer at all. The man over here that built this welding equipment that can also detoxify all toxic waste can take Brown's gas, and with Brown's gas can totally neutralize radioactive waste material. Neutralized. You can come in with 1 ton of this stuff, and he can turn it into 1 ton of inactive material. Bring him a bar, and he'll give you back a piece of metal. Ladies and gentlemen, would you say that Professor Yul Brown is just a little bit important to the welfare of the United States of America? And by the way, these eyeballs have seen what I'm talking about. I intellectually understand and know how Professor Brown can neutralize radioactive waste. And I'm here to tell you, as your Department of Energy, the man can do it. And by the way, as your Department of Energy, after Philadelphia, once we signed the pact in Philadelphia for America's Declaration of Energy Independence, once we sign that, we then are going back to our facility. We're not only going to make free electricity for the world, modify all the cars in the world, the cars that run with no gasoline at all, we're also going to bring Professor Yul Brown down to the facility, and we're going to let him neutralize radioactive waste for the entire world to see that. We invite all the people from the Department of Energy down. Come on down and see this. See the answer to the problem you created. We invite all the governments in the world to bring all of your physicists. We invite all the nuclear physicists in the world to come down and see this phenomenon. We'll show you far more than that. We'll also take a little unit that John R. Searle, with our cooperation, built. He's my partner in a building project now. We're building a little machine down at our facility, by the way. We hope to have it done about that same time. This, by the way, is a unique device. Anybody here believe in UFOs? Okay, well, I don't believe in UFOs. I believe in IFOs. See, I believe that they're identifiable flying objects because, I mean, after all, our government builds them, and they've been building them for a long time. Just north of Nevada, they've been building them for a long time. I've got friends that build them and joyride them all the time. Matter of fact, I can even show you a piece of tape, I'm not going to, but where they tried to shoot one of my friends out of the air with one of these things. Your government did that. Anyway, we're going to build some really interesting things down there because John Searle built one 50 years ago. 50 years ago, he built one, flew it all over London. Of course, he got put in prison for it because no good deed will go unpunished. I understand that phenomenon, by the way, very well. How do you think we treated Professor Yul Brown, the man that could take care of all our radioactive waste? The Department of Energy sent people down to talk to him, looked at it, couldn't find anything wrong with it, and then turned around and left. All your government sent some scientists down there. They talked to him, asked him all kinds of questions, then got mad at him because he wouldn't use it to build a better radioactive nuclear bomb. And then guess what? Then he said, well, look, I can neutralize all your radioactive waste. Why did he come to America to do that? You know why he did that? Because Professor Yul Brown grew up in the Ukraine. Professor Yul Brown was from Bulgaria and spent 7.5 years in a Russian gulag. Professor Yul Brown spent 3.5 years in a Turkish prison because when he escaped from the gulag, he didn't have any papers. He finally got to America thinking, man, if I could ever just get to America. Imagine his surprise. Guess what we do to inventors in America? Ta-da! We try to kill them. If we can't kill them gracefully because they get too many witnesses, then we try to discredit them, we try to financially deplete them, we put them in prison. Whether they've ever committed a crime or not is irrelevant. We throw them in prison. That's the way we treat inventors. Now, if anybody here says, oh, that guy's just talking out of his hat, by the way, I've been there. In all of that, I've had many attempts on my life, and I also have spent time in a prison. Although to this day, I was never convicted of the crime. Didn't even have a trial. In America, in the United States of America, do you believe that a man can go to prison and not even be convicted of a crime? Sure. Well, then I'm in an enlightened group of people here because typically in America, people think, no, not in our country. No, don't try to tell me this because I don't want to know this. Well, guess what? I agree with you 100%. I don't want to know this either. I wish I didn't know this. However, you know, only ostriches stick their heads in the ground whenever they got all of that material exposed. And so, quite frankly, ladies and gentlemen, it's time that we took control of our country. It's time that we took control of energy. It's time that the truth prevailed. It is time for God's righteousness to come forward. Your government tried to chase Professor Yul Brown out of your country. You want to know that? You didn't want to know that, did you? They have a $40 billion reward for anybody that can do that. They have $400 billion planned cost to get rid of all the radioactive waste, and I don't think they want a man to do it so economically. I think it's about big business, folks. Anyway, of course, anybody that has a brain knows that's what cancer is all about, but we won't get off into that. Anyway, now, so let's get into some more stuff. Give me the next slide here, Tommy. I'll show you guys some even more stuff. We're not even done yet. Now, are you beginning to see the kind of stuff that's been being denied to you? Oh, that's just the solar system. We can concentrate the sun's rays to get 1,000 degrees, run a Stirling engine. Next slide. And also, we don't drive ourselves crazy trying to get out there and track the sun. We just build a unit in a way the sun tracks it. Next slide. Now, let me show you the next thing right here. This is very important here because these little babies right here can revolutionize your world. How many people here, don't raise your hand, but just if you are, how many people here have known somebody that died in a plane crash? I mean, I've known people who died in plane crashes. Or how many of you have wondered if you would be the first one in your family that died in a plane crash? You might know what I'm talking about here. You worry about plane crashes because when a plane crashes, what's your chances of survival? Not very high. Not very high. And the reason why is because when the plane hits the ground, the diesel blows up and you burn to death. That's why. The explosion kills you. Now, wouldn't you be a little bit shocked to discover that there is a man named Stan Meyer, he's a friend of mine. Stan Meyer developed a technology for separating hydrogen from oxygen in water. He didn't mix the two back together again because he's not Professor Brown, but he took the hydrogen and he can use that as a fuel. Now that's an old technology, we've known how to do it for a long period of time. However, what Meyer came up with was a unique way of doing it that's practical. Normally, the amount of electricity you have to inject into water to create an electronic field, you ionize the hydrogen molecules, you can pull the hydrogen gas off. The amount of electricity you need is far greater than the amount of energy you can get burning the hydrogen, so it isn't feasible. Now, what Stan Meyer did was he figured out how to pulse the electricity into the field, still ionize the hydrogen molecules, still pull them off, and get the hydrogen, but you can get far more power than the electricity it takes to make the hydrogen. Now, to prove this, by the way, he did this in a car, but he also did this in an airplane. That's an airplane there, a jet plane, a Learjet. And your government, or maybe not your government, but the one that claims to be the government of the United States, that government actually in the Pentagon has been working with Stan Myers on this thing for a long period of time. Can you believe? For 10 years? For 10 years, the Pentagon has been working with him on this. They have known about this for a long time. Now, Myers, by the way, when he went off and talked to the Pentagon, we thought we'd never see him again, because usually that's what happens to inventors that go talk to the Pentagon. However, he came back, everything's fine, and he is working with them. Probably on something military, and so they don't think it's important enough to put this in planes. But you can take this modification with Myers' little electrolysis device, and you could then take all of the diesel fuel, all the airplane fuel, out of the gas tanks in the airplane, drain them, put water on board, nothing but water, and then you can literally start separating the hydrogen, go down the runway, take off and go up in the air and fly all over a city and have nothing on board but water. That's the fuel. Now, can you imagine how cheap airplane flights would be if water was the fuel? Well, you're missing out on that. Can you imagine how nobody would die in a plane crash if there was no fuel on board to explode? Well, you are missing out on that. And so when a president of the United States comes out and cries and tells everybody how sad he is that somebody blew up in an airplane, let me just tell you something. It's the same man of the same government that is not converting all of our planes to planes that run with no fuel at all. Does that give you some sort of idea what's really going on here? Because we have to use the fuel in the airplanes because there's a lot of money in fueling airplanes. People and their lives are insignificant, ladies and gentlemen, when money is on the line. And so I don't know if this is the American way. It's not my American way. And so this right here is another example. Next slide. Now also, by the way, we can take a little line here and take Freon out of a bottle, just refrigerant. The pressure is 100 psi. We can put it against the back end of a piston, and then this piston would be 20 times the size of this one here. And what we could do is we could push that against the smaller piston, and at a 20-to-1 ratio, we could be making hydraulic fluid over here, 2,000 psi. Can you imagine Freon out of a regular bottle giving you 2,000 psi hydraulic fluid? What could you do with 2,000 psi hydraulic fluid? You could run a motor. Next slide. Now, am I saying that you could take Freon in a bottle, run it through one of these intensifiers and do that? Yeah, not only am I saying it, I proved it at the lab many times in front of a lot of audiences. That goes to 2,000 psi. Now, you could run a hydraulic motor that would be 50 horsepower with 2,000 psi. Volvo makes one, 50 horsepower, 2,000 psi. Okay, what could you do with a 50 horsepower motor run on hydraulic fluid? Next slide, Tommy. How about this? Put one of them on that wheel in the front of your car, one of them on this wheel on the right of your car, one on this one in the back, and one on that one in the back. And now you've got hydraulic motors directly running that, the output right onto the wheel, have the power right on the wheel itself, and then you could move a lever and you could have four-wheel drive. Anybody here want four-wheel drive? And of course you could move the lever back and you could have rear-wheel drive. Then you could change it to rear-wheel drive. Would that be nice? Or you could move it in another position and have front-wheel drive. Or if you got stuck, you could dig out on the left or dig out on the right. Put the power wherever you need the power when you need the power there. Kind of a neat thing, isn't it? Next slide. How could you make that hydraulic fluid, by the way? Well, one of these babies right over here could do it with the air itself and some water. Anyway, right here now we have something that looks like, doesn't that look just like the hub of a tire, a truck tire? The reason why it looks just like the hub of a truck tire is because that's the hub of a truck tire. Right over here, some hoses going up into the inside of it, and inside that, by the way, is a hydraulic motor. And so we got a motor right in the hub of the tire of a truck tire, and that motor puts out what kind of power? How about 500 horsepower? That one puts out 500 horsepower applied right straight to the wheel. It'll run 450 RPMs. Is that fast enough for a truck? Well, take a look at the tire. You'd be going 65 miles an hour. That ought to be fast enough for a tire. Now, by the way, how would I run this? Because this requires 5,000 pounds per square inch, 5,000 psi. Where would I get the 5,000 psi? Right over there, I've got a panel. You see that panel right there? If I take refrigerant gases and I put it in the panel, the sun, the air, the wind, the rain, the sleet, the hail, everything hits the panel. Guess what happens to the gas? The gas builds up pressure up to 400 pounds per square inch. 400 psi. Now, if I multiply that 20 to 1, what's 20 times 400? 8,000. Would that be enough pressure to run that? Sure. So I could just take Freon, run it, or refrigerant gases, run them into those panels, but where would I put the panels on a truck? How about the side of the truck? 8-foot by 3-foot panels on the side of the truck, and now they're going through the air. The faster they go through the air, if you're technical and know anything about convection, the more exchanges you're getting over a given period of time, and the faster it can go. So the faster it goes, the more power you're getting against the wheel, and the faster it can go. As it slides through the air itself, it's harmlessly taking all the energy from the air itself to produce all the power into the wheels. If you wanted, you could put a couple of them inside and you could have a refrigerated truck for free and have all that power going also on the wheels. Anyway, ladies and gentlemen, there's no reason why we're polluting the air with trucks. How about choo-choo trains? If we take a look at a choo-choo train, a locomotive on a choo-choo train is 3,800 horsepower. It pulls 50 cars. That's 76 horsepower per car. Why couldn't I take the panels and put them up on the side of a boxcar? How many panels could you put on the side of a great big old train boxcar? Bunch of them, couldn't you? And as you're cutting through the air, you could be supplying all the power right into the hydraulic motor down there, powering the train. What do you need a locomotive for? You don't need a locomotive. You don't need a train engine. Each one of those boxcars could be its own power, and you could sit there with a remote control set, just like a kid with a train set, and be remote controlling all of those sets and having every other train pull them or whatever you want. Ladies and gentlemen, the world is the way it is because somebody doesn't want us to have it any other way, not because it couldn't be. Next slide. And this right here is plastic wood. Now, plastic wood is just like wood. You can screw things into it. You can drive nails through it. You can do anything with it you can do with wood. You can saw it. You can do anything else. But this plastic wood here can be utilized for anything we use regular wood for. I've always wondered, what is this insanity that we have, that we take things that replace oxygen in our air, living organisms that are there to give us vital, life-breathing air so that we can live, we destroy them and tear them down so that we can build an inanimate object to live in. I mean, ladies and gentlemen, to me, this is not very bright. Because we're losing the oxygen, losing the thing that replaces the oxygen, so we can live in an inanimate object. Now, there are disadvantages to plastic wood. For instance, it will never rot. So it will last forever. Now, this is a tremendous disadvantage. You can't live in one of them wooden things that rot and that the termites eat that you can replace, because this one, once you build it, will last forever. It'll never, ever, ever be destroyed. Thousands and thousands of years, you can hand that house down to future generations of your family, and it'll always be there, because nothing destroys it. Another major disadvantage is, once you make it blue, it is always blue. You never, ever, ever have to paint it. So you'll have to watch the football games instead of painting the house. It's a terrible thing to do to the male population in this country, that's for sure. Anyway, ladies and gentlemen, this is plastic wood, but guess what? We've got a plastic building process. We can build you a home. It is tornado-proof. I say that here in this area. Tornado-proof. Tornado comes, goes across it, doesn't bother it at all. May pull the windows out, that's about it. Tornado-proof, hurricane-proof, you cannot destroy it. We can build you a house, you take a 10-ton weight and drop it on it, it'll bounce off of it. You take an oxyacetylene torch and try to burn it, you can't. Don't try it with a Brown's gas machine, because then you could, of course, do it. But if you were able to burn it, it would burn at less toxicity than wood. This, ladies and gentlemen, is a whole new building process that will replace and revolutionize the entire building industry. We can build you a house in 3 days with 3 people. 1,300 square foot home, 2-bedroom house, 3 days, 3 people, 2 people with the roof on. When we get it all put together, hurricanes, tornadoes won't tear it apart. And you can take your shotgun or your high-powered rifle and try to put a hole in the side of the wall, and you can't do it. It will last forever, ladies and gentlemen. Of course, it'll be a whole lot more expensive than any other kind of building. No, it won't. Try about 25% of the cost to build a house any other way. Ladies and gentlemen, the things that you don't know. But you see, and if you want it to be brick, it'll look just like brick. You want it to look like clapboard, it'll look just like clapboard. You want it to look like stone, brick, clapboard, anything you want it to look like, it can look like it. The things you don't know. But you see, you can't have that, because that's going to revolutionize the building industry, and all the people in the building industry say, we don't want that. But we don't care, because you see, we're going to have these things anyway, because they're possible, and we're the consumer. And by the way, it's time people talked about the consumer being in charge and put the consumer in charge. And you know why we're going to have it? You know why we're going to have free electricity? Because somebody's going to come down there and they're going to say to you, they're going to say, no, 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 you can't buy the free electricity machine. No, you can't buy the free patriotic duty to do that. And you know what you're going to say to them? You're going to say, that's what you're going to say. I know who you people are. I know who made this country what it is. I know the spirit that made this country free. I know the spirit that beats its heart in this country as we sit here today. I know who you are. They may not know. I know who you are. And they're going to come to you and they're going to say to you, no, you can't get your car modified to run with no gasoline. It's unpatriotic. It's your patriotic duty to buy oil from Shell Oil, gasoline from Shell Oil Company. And you know what you're going to say? Same thing. You're not going to do it. And somebody's going to say, you can't have plastic homes. It's unpatriotic. You're going to say the same thing. That's exactly right. Should have sold one to Randy Weaver and a whole lot of other things, but you know what? We shouldn't have let Randy Weaver down in the first place. Okay, next, hold it. Now, I want to show you on the next slide, I want to show you something. I want to show you my plan. Do you know why this persists today? Do you know why our country is the way it is? Because we do not have a plan. We have the heart to change it. We don't have a plan. We have a clue. We know what's wrong, but we don't have a solution. We don't have a plan. So guess what? I'm going to show you a plan. The next thing is a plan for you to become totally energy independent and do a whole lot more for this country that we live in. This is the plan, and you are a big part of this plan. Now, if we're going to be your DOE, do we want any money from you? No. We're not looking for any taxpayer money. We're going to go out and build products. They're going to be profitable. You guys are going to buy them, and that's the end of that deal. You're going to save money, and we're going to make money, and that's the way it works. That's the way it's supposed to work. But here's the plan. Next slide. Here's my plan. Right here it is, all summed up. Okay? Now, over here we got the water, and we're going to take me, and we're going to stick me down in the water. I'm going to be down in the water with the big fish. That's the oil companies, the gas companies, the electric companies, the government of the United States, the DOE. I mean, you know, I'm not making any friends there. And so I'm going to be down here in the water, and I'm going to be connected here to this little rope. And when the big fish comes to take a big bite out of me, this is you right here. This is you. This is you as you sit in your chair. Now, what is it that you can do to give the big fish fits? What is it that you can do? Well, you can make some phone calls. Now, am I going to say to you that I want you to call your senator? No, I don't want you to call your stupid senator. Am I going to say to you, I want you to call the member of the House of Representatives that represents your district? No, why on earth would you call him? He doesn't care about you. I don't want you to call the President of the United States, and I don't want you to call her husband either. I don't want you to call any of these phony people out here who have usurped your rights and are standing out there acting like they care about you. Who I want you to call is people who really do care about you. I want you to call your mother. I want you to call your brother, your uncle, your friend, your associates. I want everybody in this room, if you care about us being your Department of Energy, to call ahead. You've got our schedule. You know where we're going to be having these meetings. We're going across America with the courage to say this. We want to say it to the American people. We want as many people from the American people to come out here and hear it as we possibly can. You call ahead and tell all your friends and relatives to get down to these meetings. You tell them to come down here because you know what? We are looking for a mandate from the American people. We don't care what your stupid government says. We care what you say. Because you are what's important in this country, not your stupid government. You're the people that can make this thing happen. And so now here's what's going to happen here. Hopefully not what's happening in this cartoon right here. Because you see what's happening right here is, this guy's got himself down here with the big fish. The big fish looks a little bit upset. He's about to get himself a meal. And up here is a guy named Grog. Now the plan was, old Grog is going to throw that spear into the big fish when the big fish comes to try to take a bite out of him, and they're going to eat fish tonight. That's the plan. The only problem is old Grog up here is coming eyeball to eyeball with the big fish, and it's frightening to come eyeball to eyeball with the big fish. Now I have no idea what Grog is scared of because he's sitting up there on terra firma. He ain't in the water, but he's horrified, and he ain't throwing the spear. And the guy down here, you can see his mouth open about as wide as he can get it. He's screaming, "Now, Grog, throw! Throw! Throw, 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 throw!" Old Grog ain't throwing that spear. No way. Now, by the way, this is you. You're perfectly safe. You're totally safe. They gotta have you in order to be able to do any of this stuff, or to make the factories run, or to make the country go. You're so important to them, believe me, you're in no danger whatsoever right now. Not at this point. I'm happy to get down into the water so that they can come up here, but the way you throw that spear is, you get as many people to these meetings as you can across this country. You know where we're going to be at. You call those people in Albuquerque or Amarillo, call those people in LA or wherever they are, and you get them to the meetings, and if you can, you get as many people to that meeting in Philadelphia as you can. We're going to show your government that the people in this country are very, 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 very ready for what we're coming with. You're ready for independence. And we are going to propel and propound the truth. And we believe that as we tell the truth will set us all free. We have faith in you. We have faith in God. We have faith in our country. And you know what? If we're wrong, it doesn't matter. Think about it. They put my body in a prison. They never even bothered to convict me of a crime. I walked into court one day and the judge said, "You're probably wondering why we ordered you here." I said, "Yes, because I won the fraud case." He said, "Well, we've decided to put you in prison anyway." And I said, "What do you mean, put me in prison? I haven't even gone to trial. I haven't even been convicted of a crime." He says, "Sounds like you've got a hell of a case for appeal. But you're going to prison today because I've been ordered by the state of California to put you in prison." And I said, "Well, wait a minute here. You can't do that. How can you do this?" He says, "Well, you probably don't know how it works. So you go over there, the guy with the gun on his hip, he puts the handcuffs on you, he takes you through the door there, and you're in prison. Let's try it." And I went to prison on a 4-year rap in prison, and I want to tell you, I am so thankful to you people for putting me in that prison. My body has been in prison, but my heart and my spirit has never been inside of a prison. And I wasn't in a prison then, but I've never had more time to think. It was wonderful. And I deeply appreciate the opportunity I had at the California state-sponsored think tank to develop this whole plan and to come up with all the technologies. 17 technologies came out of my years in prison. I consider it one of the most fruitful periods of my life. And so, ladies and gentlemen, let me tell you something. There is nothing scary about the position that you're in unless you don't do this. And then there's going to be something kind of scary about where you're at right now. Because right now what is happening is, and anybody can see it. Look at it. We have lost our competitive advantage. We have lost our free enterprise system. Now all a man has to do is not develop a better product, just make sure his competitor's happy with it. All we got to do now is just don't rock the boat. And then the boat rolls along with no new competitors, no new technologies, none of the creative things that God has. Do you know who develops all inventions? God does. All creativity comes from God, ladies and gentlemen. All creativity comes from God. If not, then we would have had it all along. God decides when we're going to have it, not David Rockefeller, not Messrs. Rothschild. I would like somebody to show me one star that David Rockefeller ever hung in any part of the galaxy. One star that Messrs. Rothschild ever put in the galaxy. All of these people that we're concerned about are not God. They do not have godly power. They merely exercise the rights of a bully over someone that doesn't care enough about his assets to lock the door. And so, ladies and gentlemen, let's stop this crap. I'm ready, if you're ready, and I, by the way, am not just a man. We have 2,000 dealers in the United States of America. We're in every state of the United States right now as we sit here. We have factories, we have foundries, we have money, we have people who are every bit as determined as I am, and they are going to have to kill most of us to get us to stop. And so, ladies and gentlemen, they won't do that. When I have people coming against me, do you know how many people came against anyone else in my network? None. They came against me. They don't come against you. They try to sweet talk you. They try to tell you how bad I am. I'm going to say one last thing to you guys, and that is, there are people who have said we're a scam. You know that? There are people who have said we're a scam. This is funny. We're a scam. But you see, if we're a scam, we got to be the stupidest scamsters in the world. Why would a scam stand up on this stage telling you things, wondering if he's going to make it to the next time to tell it or not? I mean, folks, scamsters don't get up here and tell you how bad your government is and all that stuff, expecting to get shot before the day is over. That's not the activity of a scamster. A scamster is somebody who wants to enjoy the fruits of his scam. Not somebody who wants to antagonize everybody in the world and get shot before he gets out of the door. And also another thing about scamster, I got to be the dumbest scamster in the world. I was worth $50 million when I started. Now all I got is the technologies that don't work. That'd be the dumbest scamster in the world. I changed 50 million cash for a bunch of technologies that don't work. And by the way, also pretty stupid scamster, we did this show in March 5th of this year for the Congress of the United States. We did the show for Janet Reno. We invited her. We invited the head of the BATF. We invited the head of the FBI. We invited the whole entire Federal Reserve. We invited every government official and posing government official in Washington, D.C. People that were officials and people that you only think are officials. We invited them anyway. We invited them all to come down and see what we're doing. That's the stupidest thing a scamster could ever do, isn't it? Right there in Washington, D.C. And they came, some of them. The ones that didn't come, we called them and we said, look, we videotaped the thing, you didn't make it. We want you to see this thing. Will you watch it? If we give you a copy, we got a commitment from every one of them they would watch it. And then we hand-delivered the copies and made them sign for them. Your senator has seen this, ladies and gentlemen. Your member of the House of Representatives has seen this, ladies and gentlemen. All of those people who you call all the time have seen this. Don't call them. Because when you call them, 1 million people will call, and they'll say only 3 people called, and you'll be standing there wondering who the other 2 were. They don't have to tell the truth. Okay, as a matter of fact, their occupation requires that they not. What do you think a politician is? I mean, an honest politician is an oxymoron. So anyway, all I want to say to you is, I have got the courage, the divination. I have been, I believe, led to do this. I'm not afraid to do this. We have the network of people that are behind this. We have the determination. We're not afraid to do this. If you can please get people to these meetings, then we will build an uprising across the country. We will reach critical mass. We will start distributing these technologies to you all across this area. If you're here, how about this? We put one on your house and we charge you nothing. That's what we're trying to get worked out. Your cost, zero. And how many friends and relatives and neighbors do you think you'll have that won't want one of these? And as they work and as you do it, that's an unstoppable movement of the people. Ladies and gentlemen, it's a mandate. Ladies and gentlemen, it's where the people said, enough. We're not going to take this anymore. We're going to make this change. And so we're here with the technology. If you guys are here with the people, let's go get it done, okay? God bless you guys. Now, thank you very much for coming out here tonight.